I see more folks starting to join. We will get started in just about 5 minutes. Thanks so much for coming back and joining us today. Okay, bringing myself back on screen and on camera. The camera will show up. There it is. Good morning, everyone. How are we doing? Thanks so much for an excellent day one of the Educator Summit. We had a great time. This was awesome. And thank you so much for coming ready to learn and with your questions. Want to give a quick recap for anyone who wasn't able to join us yesterday. What we went over, we had a couple of really lovely presentations from PJ Metz, our education developer advocate, who gave us a GitHub 101 and 102 session. And then we had a lovely session after lunch from Ari, who is on our GitHub Learn team, and walked us through skills exercises, how you can learn GitHub within GitHub, and also a little bit of sort of how you would then create custom skills through using Copilot, as well as using GitHub and GitHub Actions and a few different things. I want to give us, or I want to give folks some resources from that, from those sessions yesterday. And then I want to share a little bit about what's going to happen today. For today's session, actually, I'll get started with today's session first. So for today's session, we will be doing several things. So we're going to get a welcome from Martin Woodward, our VP of Developer Relations. We're going to hear a little bit about sorry, my mic is, okay. We're going to hear a little bit about the working group that we held on Tuesday here at GitHub HQ. So we had an in-person working group with a small amount of folks, about a dozen or so educators from around the country who were doing a working group to tackle like tool building in the, kind of the world of AI, and how you can make things with AI to enhance and to kind of like address the shifts in CS curriculum, but also just sort of in general, what sort of shifts are needed in CS curriculum to really address the shifts in AI in the industry as well. We will hear from Swift at MLH, Major League Hacking, one of our partners, and he's going to really talk in broad strokes about LLM use, AI use in general in the industry, how that's useful for partners, students, and teachers, and then also a little bit, dive a little bit into some introductory Copilot. And then Ari will come back. We'll learn a little bit more today and dive deeper into credentials and credentialing. And then he's going to actually pull out some modules and some workshops from the most kind of like current and most like newly launched credential, which is developing in AI agentic systems. So you'll get a little bit of hands-on Copilot work today as well. And then let's see. Oh, yeah. I'll address some of those questions as well. And then we will have open learning hours as we did yesterday. So if you weren't able to join us for the open working hours, they're really great because it allows you to really get some hands-on assistance with a few different topics. So I'll have breakout rooms set up for you to walk through different issues that maybe you had during the day or questions that you had during the day. Today, we're going to be joined by a couple of campus experts or student community leaders. So it's going to be a really great breakout session with prior learning at the end of the day. So the final 2 hours of the day will be dedicated to that. And without further ado, I will link the full schedule I just kind of like walked through in just 1 second. It's in the teacher toolbox as well. But I'd love to welcome Martin to the stage, so he can give you a little welcome. I will remove this from the screen and bring Martin on if you're all set to go.
Hey everyone, thanks for joining. I hope yesterday was good, and thanks to the team for putting this together. Basically, won't take too much of your time before we hand over into the content that we've got coming up. I just wanted to thank everyone. Obviously, you know, together shaping the next generation of what it means to be a developer at a time when what it means to be a developer is kind of changing massively in the industry, and we're all kind of trying to figure out exactly what that is. I have a lot of skin in this game. My son graduates on July the 7th from a master's in computer science, and he's going to be going into the workforce, fingers crossed. Well, he is. He's got a job lined up, so that's cool. But heading off into the workforce and things. And part of that the past, he's done an integrated master's. Part of that whole kind of 4-year journey has just reassured me how important a formal computer science education is in shaping the next generation of engineers and developers, but equally how important it is that we stay on the cutting edge of what we do and how we build things. Some of the courses around him like learning the basics of AI and doing tensors and doing all that sort of stuff has been incredibly important in understanding what's actually going on in the industry from first principles. But also having access to AI tooling and things like that has been very important. Knowing when to use it and when not to use it. He just recently did his quantum computing like exam, and knowing to kind of switch things off and when to study and then when to lean on has been vitally important. All that taught because of amazing educators like we have here who are on the very, very bleeding edge of what the industry is doing and how the industry is changing, and then trying to shape the people that they're talking to have the best view on that. So appreciate all the work everybody here is doing. We're keen that we do it together as a community, and what we're not doing is, sending down tablets from on high of like, hey, here's this, here's the answer, because we don't know, and we're the least likely person to know. You are the people who know where we should be going, and more importantly, this community together is what's important in figuring out how we do things, sharing best practices, learning from the different folks on this call as part of the community, keeping this community going forward as well, and making sure we share. When we're all looking at grants and stuff, and when we're all like looking at institutions, it's very easy to think of ourselves as competitors sometimes, but we're not, and we're all kind of there's a very big pool of people that we're trying to do. So as much as we can work together would be fantastic. So today, as Morgan said, we've got some great stuff coming up. We're obviously going to be digging in and kind of recapping a lot of what we talked about yesterday, and do some AI upskilling. Then I'm very, very, very excited with for the Copilot workshop with my good friend Swift, who's going to be chatting you through and sort of talking through some of the stuff that MLH have been working on and driving there. And then obviously Ari and the agentic AI systems is great. The last thing I want to encourage you to stick around for, I know sitting on the end of a Teams call isn't always the most exciting way to spend a day, but we have Codio and 50 Foundation on towards the end of today. And when I talk about community, this is exactly what I mean in terms of what do we do with some of the functionality that, say, GitHub Classroom was kind of helping address, but never really did an amazing job of addressing. How can we as a community come together and address that together? So we have Codio coming on and talking about their solution, but we also have David Mallon coming on and talking about the 50 Foundations work, where that's trying to build a community forward solution of how we do automated marking, how we do some of these classroom types environments in an open source style way, which fits exactly on top of GitHub as well. So both solutions we think are going to be great. Both are different options that are great for different people, but they only will work for you if you work with the communities around them, and help shape them into be the products that you need. So yeah, please stick around for that last session on day 3. The last session on Friday for that. Last but not least, I wanted to thank everybody here for taking the time. You are the cutting edge of educating our next generation, and you're doing it in the best possible ways by working with the industry, working with each other, working with open source, and you are not giving people a theoretical grounding in how computer science is going to change the world. You're giving them a very grounded by reality way of how things are doing. And as we know from AI, the better grounding you have, the less hallucinations you have, the more accurate things are. And so by continuously doing what you do, by working with the industry, working with everybody else in the academic community and within the education community, that is the only way that we'll continue to evolve and continue to adapt. The future's changing incredibly rapidly. Predicting what's going to happen in 6 weeks' time is hard enough for us in the industry. So I've no idea how you build curriculum that's going to last for 2, 3, 5, 6, 10 years kind of thing. But we know it's going to be exciting and we know it's good, and we know that we're going to need more developers than ever before in the future. We also know that developers that are coming into the industry now are so much better equipped to lead this AI-powered wave of development than a lot of people who are fairly senior in their positions, but maybe haven't been keeping on top of technology. So the more you can do there to help shape the future generations is fantastic. The more you can do to help shape the future of research as well. There's a ton that we can do in terms of applying AI into research fields and helping scale that out. And again, the more that we can do this in the open, the better. You all kind of help change the world of education, one pull request at a time. So thank you very much. We want to continue being your partners in this. So let us know how we can help. And I'll hand back to Morgan. Maybe.
There I am. Am I here? Yes.
Yep, there we go. Hey, Morgan.
Thanks so much, Martin. I really appreciate you taking the time as well to come and visit with us for a little bit. I will kind of like do a rundown of the rest of the day. You're welcome to hop off. We're going to continue on with our day, but thank you again for coming in and kicking us off for day 2. We have some really fun stuff in store. So thanks so much. All right, everyone. So the next thing we're going to do is going to address a few questions that I'm seeing in the chat just really quickly. I want to share some resources out and make sure y'all have some of the links that are going to be helpful for kind of like recapping yesterday and for what's upcoming for today. So we are sharing all recordings of every session we have. We are recording everything and we are sharing everything. We're going to be sharing it next week likely because we want to make sure that the links we're sharing can correspond to every session in a way that's like really easy for you to find and consume. And so all videos will be available. Please do not worry. We are going to send them out. We know that everyone is not able to join at the exact same time zones. We tried to put it as early as we could on the Pacific time zones so that as many people could join at least the early parts of the day. But we understand that not everybody can join every session. So everything is going to be recorded and shared. For today, we sent out an email to a number of folks because we want to make sure that you have access to Copilot Pro for today. Avni's going to pop in and share a little bit about any next steps that y'all might need to take. You should have some of you got an email from her, not everyone, so don't worry about it. If you did not get an email, that's a good thing because that means that you probably we already have the information that we need from you to be able to get you the Copilot Pro access. But if you did get an email from us, Avni's going to tell you a little bit more about kind of what that is for and what you can do to help us out.
Yeah. All right. Thank you. Hi. Can you all hear me okay? Yes, I hope so. Okay.
Thumbs up, yeah.
Thumbs up. Is there enough thumbs up?
Yeah,
Okay. Thank you so much. Okay. Thank you. Hi all. Welcome back. I'm excited for day 2. It's great to have you all here again. Excited to see people trickling in. I think today is going to be a powerhouse of a day. I want to make I want to make sure that you all have the resources you need to be able to follow along with today's sessions, which means making sure you get your teacher benefits and have access to Copilot Pro. So if you received an email from me, the email is my first name, Avni, AVNI, @github.com. Please check your inbox, because if you received an email from me, there's at least one step you need to do. Some people need to do 3 steps, but most folks only have to do 1 or 2 steps just to get their coupon and get Copilot redeemed. I want to make sure before the technical sessions start that you all have access to Pro and you're already on Pro, so you can just go like move forward with some of the agentic workflows. By default or without a coupon, you can get access to Copilot free, but that likely will not be enough for you to do what you need to do today. So please do look for that email and follow those instructions. Very excited for what we have planned today, and looking forward to what's coming. I will paste a few resources and links from yesterday. I know folks have been asking about that have come up, just so everyone has them. And then I saw a couple of questions come in about the sessions being shared. I think Morgan covered that next week. So if you can't access it, the only way you can access the sessions from the meeting recap is if you were here yesterday, right? Or today. Like, you have to join the meeting to access the meeting recap. You have to be a part of the meeting. It's a privacy constraint that Teams has. Otherwise, you'll have to, if you have colleagues that, want to watch the recording, they can watch it next week. I'm just checking a couple of the Q&As as well. I think there was one more question about which tools or IDEs will the demos and follow along exercises be? And I think that's a great question. You can use VS Code or Code Spaces for the exercises. We'll also cover some of the CLI and the GitHub Copilot app as well. So you're going to get a flavor of different ways to use Copilot today. I think one of the challenges with AI is there's so many tools out there, and it's like, what do I use for a specific task? And today is about giving you a flavor of the different types of tasks that exist and how to go about it, and how our experts here would recommend going about it. Want you to try and see, and then try it out, see what works, and then have enough information at your disposal to make the choices that are right for you. So that's our hope today, right? Our hope is that you come out with experience with Copilot, understanding what agentic workflows are, and then having some exposure to some of the tools available so that you can then choose for yourself as you decide on the tasks and the outcomes that you're looking to achieve, what tools are right for you. Again, check your email, and thank you for being here today. Morgan, back to you.
Okay, there you are. No, you're all good. Okay, so a couple of things to share between now and 10 o'clock. For folks who were not able to join yesterday, I wanted to share out some helpful links and resources from our presenters from yesterday. So to start us off, PJ, our education developer advocate extraordinaire, a lot of what he was doing is from this that I just shared in chat called Learn with PJ. Those GitHub 101 activities is what he did in the first part of the day. So the first session of the day was GitHub 101, and it was a lot of Git, kind of a slight introduction to Git itself and version control, how GitHub kind of works, the ecosystem, and then the exercises themselves are all in, or for the most part, are all in this website that he created called Learn with PJ. And so there's creating a profile README, collaborative activities, creating and solving merge conflicts, things like that. This is largely what he was covering kind of like yesterday morning. So you can really kind of like dig into some of what he was doing there if you go there. The other thing I wanted to share really quickly, again, was the teacher toolbox, and specifically the agenda page for the teacher toolbox, the schedule page for the teacher toolbox. So you can have a sense of what we covered yesterday and what we're covering today. For yesterday afternoon session with Ari really went into GitHub Skills. So GitHub Skills is how you can basically learn GitHub on GitHub. So it's learning GitHub with GitHub. And so I'm going to link to the GitHub skills site because it's really helpful. It has things like for your first week on GitHub, your first day on GitHub. So he kind of walked through the sort of structure of GitHub skills, how they work, how they sort of work with actions. And then he dove into how you can create your own custom GitHub skills exercises using a skills exercise creator and with the help of Copilot. So I'm going to share that as well in the link. The link is in the chat there. So you have a little sense of what he was doing, and he kind of demoed and walked through it as well. So we'll have videos for that, but I don't want folks to feel if they weren't here yesterday and you know the videos yet that you're very behind. Like Avni said, this is sort of like we're giving you a lot of information so you can kind of like take in and absorb what you'd like to see how you'd like to incorporate it into either your own work, your own professional development, or your classroom. So all the resources are not kind of like going to build on each other so much that you're going to be lost today if you weren't here yesterday. These are really just kind of resources for you to take and use going forward. So wanted to mention that. So I don't want folks to feel like they're behind or anything like that. The other link I wanted to share, which is going to be really, I think, important going forward to give a plug, is there's an event coming up that I think actually will be available in a few different time zones. And it is a session from GitHub Learn called Usage-Based Billing with Confidence, Agent Quality, and Token Optimization. So it's really about how you can efficiently use your tokens and your Copilot Pro and Copilot Free and Copilot Student, right? If you're kind of telling your students about it, with kind of like with efficiency. So that I just dropped the link there so that you can register for that if you're interested. And so for the next few minutes, between now and around 10 o'clock, when we have on the group to give us a slight recap of the working group, we're going to just kind of like manage some of the Q&A and some of the questions that we're getting in. See if you can help troubleshoot with y'all today on a few items that seems to be outstanding. So we will be back in basically in maybe like 5-6 minutes with the next session. And so for now, we will be sort of helping with some of these questions and things like that. So sit tight. Appreciate it. Appreciate you all being here today, and I'm excited for today's sessions. So feel free to drop stuff in the Q&A or in the chat if you have some other outstanding questions, or if any of the links didn't work for you, if you have any questions about some of the resources that we're sharing. I'm going to mute myself for now, and we will see y'all soon.
Hello.
I'm using a different room. Hold on just a second. Okay. Hi, folks. One other thing, just wanted to share. We're about to have Corey Gwynn on, who is a senior software engineer who's been helping us a lot with understanding CS changes from an engineer perspective and how those can influence CS curriculum. Just wanted to say we are working kind of like in real time with the analyst team that we have on staff to resolve some of your questions for folks that are having trouble getting verified. So if you feel comfortable, dropping your username there, we can help there. We are often able to manually accept someone as long as the application has been submitted. So looks like we're working through those. Avni is on top of it. And thank you again to Phoebe for answering so many questions I'm seeing in the chat and in the Q&A. I think that I'm just trying to see if there's any good tips in here for anyone else to have, but in the chat. Don't think so. I think we're doing pretty good. Yes, okay. I think we're doing pretty good. And we're getting through it. You can chat us throughout the day to address some of the things that Avni mentioned, including getting your access, kind of like making sure your access is there. GitHub Classroom extension is deprecated in VS Code. What should we do? You should come to tomorrow's session. So GitHub Classroom is being deprecated. We have two transition partners that are going to help us kind of like evolve into the next version of what that's going to look like. Codio and the 50 Foundations. There's going to be two different versions that could be based on what you kind of like would like to do with kind of like moving forward with classroom and the classroom transition. We're going to be helping folks get migrated over to one of those two solutions. But the best thing you could do is really join us tomorrow, because tomorrow is all dedicated to classroom, and sort of a little bit of background of what the timeline looks like on the sunset. And you'll get to hear from both of those partners that we are working with now to transition. So they're going to be doing full demos, and they're going to have time for Q&A as well, for how they're going to be actually operating with kind of like migrating all folks in, and how you can get spun up on some of the new tools that you're going to be using with them. For folks that are seeing the free version, okay, Avni's going to be talking about that in chat. She'll address those in chat. I'm going to now make sure that yes, I'm going to make sure that we're ready for our next session, which is going to be in about 2 minutes. So I'm going to leave for a second. I'm going to welcome Corey onto the stage, and we will have a few folks that are going to be helping us. They'll introduce themselves, but I want to have Corey kick us off, because we will be he's the visionary of the working group, and so he's going to tell you a little bit about what they did and his approach to what they did, and then we'll hear from a couple more educators as well, who were at the working group and participated, and we'll hear a little bit about what they built, and how we're thinking about it moving forward. I'll also say that we'll have more opportunities for hopefully summits like this and working groups in the future, but this is a little taste of what we were able to accomplish earlier this week. So I'm going to mute myself.
Can you hear me? Am I on? Am I live? Am I talking? All right, cool. I have no
You're
idea what's
on.
happening.
Yeah,
Good.
you're on. Go ahead.
All right. So hello, everyone. I was fortunate and delighted to work with a brilliant group of forward-thinking educators to kind of explore an idea I've been writing about on my blog a little bit, and take this idea that I have of what I kind of think is going to happen and how things are changing, and present it to them, and then teach them how to use some tools and just kind of let them run with it, really. Um, so I'm going to kind of share with you a little bit about what I was thinking for the workshop, and kind of what I rooted the whole thought process within. And then Leo is going to talk a little bit about his takeaways from the workshop and kind of, I'm going to give him space to say if it was great or he hated it. Either one is fine. And then Jeffrey Challen from the University of Illinois is also going to speak following that. So I'm going to share my screen and kind of take you through what we were thinking about and working on. So on my blog, a few months ago, I wrote this article called "The Split is Real." And that was kind of the framing for the whole thing. And the idea that I keep coming back to is like everyone can write software now, like everyone is a maker. And that's a huge opportunity. And I've seen this happen in the real world. So I have a neighbor who works for a small financial company and they pay just tons of money for Salesforce. And they don't use most of it. They only need a small portion of it. And him and a couple of the people he worked with used AI tools to build the parts of Salesforce that they needed, and they shipped it, and they completely replaced this huge tool um, and saved the company $250,000 a year. And he is not an engineer. They did need some help. They worked with some engineering folks that they knew, and I helped them a little bit as well. But like, that's an amazing accomplishment. Um, but we also live in a world where, we have staff engineers being paged at 2 in the morning because an AI assistant like wiped out a production database. Like this is happening, and both of these things are really happening right now, and we see that in the numbers, right? Like it's fascinating, like the different users that there are now, and how things are changing. Um, AI isn't changing how engineers work. Not just that, it's changing who gets to build things, who gets to be an engineer. And to me, that's really exciting, but it's also like super scary. Um, and I think that there's really 4 layers of people that we now are kind of seeing build software, and they all support each other. Like it's like this triangle where it's upside down, and the problem focused builders, layer 1 that I call them, is just going to be massive. Like it's going to be at some point it's going to be everyone. Like we can push down the abstraction layer so much that people like anywhere can build anything. And that excites me because that means like nonprofits can build the tools that they need to do their job that they don't have access to today. But we really need to also put the people in place who support them. And each layer gets more and more technical in their abilities so that they can support the less technical people who are, above them. So I think that there's an opportunity as educators to start thinking in these layers and kind of expanding who you're teaching um, and really change things. And they're really roles. They're not ranks. Like I don't think that one is more important than the other. They're just different jobs. But there is a lot of risk in being a software engineer today, and we're kind of handing these really powerful software engineering tools to everyone. And those people don't necessarily have the rigor to do it in the way that they needed to, and the AI isn't good enough yet to really, match them where they are. So there's a lot of problems to be solved in this space. Um, if we think about tools moving up the stack, right? Like a teacher solves their own problem and then they're using it in their classroom and they want other teachers to use it. So they need a way to hand it off to someone to like get some help to make it accessible to more people. Maybe that means adding authentication or getting it deployed somewhere where they can use it. And then there's the engineers above that are giving them the places to do that thing, right? And above that layer, there's like a scientist who's never touching this tool in any way, but they're building maybe the hardware that it runs on or optimizing the AI that it's built with. And all of those people are people that we need to train and we need to teach how to do their specific layer of work. But also like everyone is really going to be a layer 1 user as well. use this analogy where my great grandfather was a shipbuilder, and I have a whole bunch of tools of his that he built. Like he built them to do his job better. And as AI becomes more and more capable of building tools, everyone's going to be building small tools to help them do their job better. And so you're always going to be kind of working at any one of these layers as you move up the stack. And that stack actually gives you kind of a natural pipeline, right? Like if you can learn layer one, well, now the next thing to do is learn layer two, and then layer three, and then layer four. So you kind of move up. And we need the systems in place to kind of help that like happen, right? In industry, we need apprenticeship ladders, or, CS curriculum needs to, start at layer one and then move people up the stack, I believe. And they can kind of stop wherever they want to, right? Like there's a lot of people who will never move past layer one. And I think we've always kind of had this in software engineering, and we've hidden it. And it leads to a lot of problems in industry where like there's a lot of people who are really good at like understanding a domain problem and then trying to build a tool to fix it. But like they think that they're imposters because they don't value their ability to think about and solve problems. They only value their ability to write complicated code. And a lot of people write really complicated code to try to move up and get a promotion when it's really not justified or needed. We need to be able to value all of these roles. So yeah, so this split is really happening, and there's going to be a lot more layer one engineers is what I'm thinking. And that's a really amazing thing because that means that we have more people building tools, and the more people building tools, the more we can shape society. So that was kind of the premise for where I like put people. If you want to read more about it, I write about it on my blog, along with other things, but it's coreyguin.com. And after I laid this groundwork, basically I taught everyone in the room how to work with AI in an effective way to build things. And then we spent the afternoon talking about these different layers and what we think they need to know, and then trying to build things to help improve our classrooms and learn. But really, the goal that I had was not necessarily the output of what they built, but just to get everyone in the room comfortable working with these tools, because I think every educator should try to build tools to help them do their job. And if you can become really good layer one users, then you can teach it. But also, you can become better teachers because you have better tools. Yeah, so that was the framing. I'm going to hand it over to Leo to talk about his experience and reflect on it. He's also doing some really cool work in this area as well, so I'm sure he'll want to share a little bit about that.
Hey, Corey, can you hear me okay?
Yep.
Awesome. Let me share screen real quick. And thank you all for the opportunity to talk both about the amazing workshop that you all ran the other day and also about some of the work that we've been doing. Is this coming through okay? Oh, good. Looks like it is. So let me start actually by thanking Avni, Morgan, Corey, and PJ for running an amazing event on Tuesday and for running the events today, this week. I also want to apologize. It's finals week here at UCSD, so I'm hopping in and out of sessions, but we're also grading and all that kind of stuff. My goal is to just share a little bit about the work that we do in terms of helping faculty adopt generative AI into their coursework, but then also share the lessons that I took away from Corey's amazing sessions on Tuesday. All right, so Corey's already covered the fact that industry is changing because of generative AI. I don't think I need to make this point anymore. I do want to share quickly a really nice study that came from Google this last year, which shows one of 4 key skills for successful software engineers today is working with AI. And this would not have been on the list 3 years ago, right? The other 3 are still there. They're before Gen AI, they're still there now. But now we have a whole new skill group within the top 4 that's shown up in the last couple of years. And the challenge with this new skill existing is that industry doesn't feel academia is preparing students well for this. So there's a really nice report that came out of Digital Education Council, who are partners with Google on a number of initiatives. And what they found, if you jump down to the second bullet on the 3% of employers, 3% believe that institutions are adequately preparing their graduates for an AI-driven workforce. That is wild. And so we need to close this. There needs to be a way for us to prepare our students for this new workforce. And the challenge with this is I don't think we in academia are united on this topic yet. And so I just want to share one of the nice things that I get from being a co-director of the consortium that I'll talk about in a minute, is I get to talk with a lot of faculty across the nation, across different countries, and I get to hear the different perspectives of faculty. And to be honest, we're kind of all over the place. So I'm going to give you just a couple of the example paraphrase quotes that I've heard from various schools within the last year, but I think they represent different lenses on the spectrum. So the first is saying, you don't get to use AI unless you can do all that from scratch first. And I get this. This is a first principles. It's a pretty classic approach to education. It's a valuable approach, I would argue, to do first principles. But it's challenging to figure out what the first principle is supposed to be. Where do you start building up from? I don't think any of us would argue we start with transistors before we get to write code. And we've taught in Python for a long time, or Java. We haven't been teaching in assembly. And so we decided that we want students to be able to build things early in the curriculum. And so why would they not be allowed to use generative AI tools earlier? So that'd be kind of the counter to this position. We also hear, the people in industry are using these tools just fine, and we train them the old way. And so why should we change anything? And I think one of the nice lessons I got from Corey and a number of other folks that I've talked with, as well as some teams that upskill existing engineers, is this isn't as natural as you might think. There are actually real skills here that need to be trained, and it can take some time to learn those. And so we do actually have new skills that could be added to our curriculum. This is perhaps the farthest extreme I've heard of faculty saying, if a student were to hire another person to do any of their coursework, that's contract cheating. If they hire an AI to do any of their coursework, that's contract cheating. And I think what this position is maybe arguing for is we don't want students just copy pasting from generative AI. Like that doesn't seem like an effective way to learn. And that's not what I think we're hearing today or yesterday or tomorrow from industry. We're hearing there are new skills to be taught, and we want the students to learn these skills. And it's not just about copy pasting from generative AI. And then lastly, and this is the other extreme I think I heard, which is essentially arguing we as a computer science program may become completely irrelevant. Like we'll be teaching the equivalent of classic Greek to help students read the Iliad, because maybe then they could write do creative writing. And I think the extremes here kind of show how divided we are on this topic of industry preparation. Now, this isn't a new problem. So I just want to point out that there's been decades of research showing that there's a divide that has been created between the skills we teach in CS programs and the skills necessary to succeed in industry. And a nice quote from Titus Winters, I'm going to give you another one here in just a second, is that most CS curriculums today look like what was necessary to build a database or an operating system in the 1990s. And he's not far off, right? We have these, I'm not going to list all these, but we know these are standard things that we tend to underprepare students on. What's missing here is also being able to have strong soft skills to work with teams. And I'm going to argue that this gap has been forming for the last 20, 30 years. And I feel like AI is just one more addition to that gap, and it could be the straw that breaks the camel's back. And Titus made a nice point on this, where he argued AI just makes old problems urgent. And I agree. Now, the good news is that some research that's been done by Sandra Volstar out of UC San Diego show that faculty actually do care about preparing their students for industry. There are some faculty who will argue we're not a vocational school, we're teaching higher level fundamentals, but most faculty actually really want their students to succeed when they graduate in industry positions. The problem is they face barriers, right? Those industry skills aren't necessarily already in the curriculum, which means we need curricular change. They have challenges making meaningful assignments that can work year after year, that are large code bases, for example. And then lastly, many faculty never worked in industry. And those who did often worked there 20 years ago. And so it's hard to keep on top of the different practices, which is why sessions like this are so critical, because they get us up to speed in what industry practice is today. And the good news is most educators recognize that the skills to program have changed fundamentally because of generative AI. And the challenge is that only a fraction of them have actually done anything to change their courses. And so that's why we created the Gen AI for CS Education Consortium. It was a generous gift that came from google.org, and it was meant to support educators as they navigate this change. I'm going to give you a couple links here in just a second. We work with a number of partners that are faculty facing. So our goal, again, is to support faculty. And because Computer Research Association, ACM-SIGC, the Computer Science Teaching Associations, they already have communities of faculty, we've been supporting them in making change happen for their communities, as well as hosting 7 courses within the curriculum that have been designed by various faculty to help integrate generative AI. We do a lot of outreach to help share these materials with the community. If you go to teachcswithai.org, you can find the resources that are available. And we also have an active community of practice of faculty who are working to make change. The courses, if you're curious what's in these courses, they essentially have 2 key components. The first is they've updated their learning goals to reflect what's necessary to succeed when working with AI. And the second is they have redesigned their assessments such that students are using generative AI to complete take-home assignments. Some of the courses then have students actually demonstrate their skills in testing in a test setting afterwards. Some do not. But these are the 2 key elements of each of these courses that have been changed. All right, so that's the bit about the consortium. I'll throw a link up about the consortium again at the end. But let me share the 2 things I got out of day 0. And it was really hard to figure out just 2 things I learned in those incredibly powerful 6-7 hours we got to spend together on Tuesday. The first is software creation has changed a lot more than I'd realized. I think I've been very on top of early work with autocomplete, with working with chat, some even early agentic workflows. But I had not seen the kind of workflow that Corey showed in our workshop. And I'm really appreciative that he's sharing this all with you. But it was incredibly eye-opening to see how much things have changed and how much you can use these agents to succeed. One piece that came away that's a little bit on the trickier end for me is I could tell, sorry, Corey, I'm putting you on the spot here, that Corey has a lot of expertise. He's developed this over time working with these tools. And I haven't quite gotten the snapshot of Corey's brain yet to see what are these new skills? How did he develop them? What wasn't taught before? And I think one of the next big challenges we have is to figure out what exactly these new skills are so that we can then translate them into the curriculum. But they're clearly there. And I just don't have a handle yet. And maybe to Corey's earlier point that I need to spend more time doing these practices myself to develop these skills so I can learn how to teach them. The second, and I've been saying this for a while, but it just came through so cleanly in this event, is in the past, academia and industry, I think, has enjoyed a fairly close relationship, but I think we need to be even closer in the next few years. We have to lean into these collaborations. Events like this that GitHub's putting together are invaluable. And it's twofold. One, academics, we need to hear from industry. The people in industry are essentially the front line in adapting to these tools into their professional practice. And if we want insights into what that professional practice looks like, we need to be talking to industry, or industry needs to be sharing out like Corey's doing today. The other piece, though, is that industry isn't always aware of the challenges that academics face in teaching students. They may not be aware of the levels of preparation students have coming in. They may not be always aware of the administrative challenges that academia has. And so this collaboration is 2-directional and I think is incredibly valuable. We all learn from each other through these conversations. So I think I'm at times. So I just want to share again, this is the link if you want to learn more about the consortium and get more support in integrating generative AI into your curriculum. And let me thank Corey, PJ, Abney, and Morgan one more time for putting this all together. Thank you.
Awesome. Thank you so much, Leo. And it was really great having you there. And really cool to hear what your takeaways were.
Thank you.
There's also a bit of like, I don't know what the skills that I've developed are either.
We need to dissect the brain and figure out where that is. Yep. Thank
you. Yeah. Cool. And next I want to ask Jeffrey to share his takeaways as well. Cool. Thanks, Jeffrey.
Can you hear me?
Yes.
All right, let me share my, oh no. Sec, I guess I'm gonna have to quit and reopen Teams, so just give me a sec.
Okay, we'll have to play some like Jeopardy music or something, because, technology. Yeah, I hope we can do more of these things for more people, because I think to Leo's point, there's like a lot of skills that we're developing in industry that are not evenly distributed even inside of industry, because there's a lot of people just trying things and figuring things out. And not everyone is doing them evenly, even inside of companies like GitHub. Yes, Abby.
Hey, I just wanted to, I think Morgan answered the question in the meeting chat, but Leo, a few folks are asking how they can access the community of practice you mentioned. We're going to point them to the Slack for the consortium and the website. But if there's anything else that we should provide them, Leo, if you could let us know, that would be great. I think, oh, we lost Leo potentially. No, he's here. Okay,
the
great.
Slack
Okay.
and the website would be fantastic. Thank you for sharing that out with folks.
Yep, amazing. Would love to have more people join the consortium, more educators join the consortium. The summit this year in San Diego was amazing. The talks were amazing. The research outcomes discussed were fantastic. So just love the collaboration that's happening here, and really want to thank Leo and Jeff for participating with us on this journey as we figure this out together. Really, really grateful. I'm grateful to have a leadership like Martin who's, understanding that the value in investing in the next generation. So it's really great.
Thank you.
Really appreciate y'all being here.
Oh, and I appreciate you mentioning the workshop that we read, and we will have another workshop next March. So people want to have kind of in their back of their thoughts, we're going to be having another big event next March to share out to the community.
Awesome.
Thank you.
And Corey for making it all happen. Amazing. Is he back in? Yes. Okay. Great.
All right, I'm back. Sorry about that. So yeah, thanks to everyone who organized the event. I will echo all of Leo's appreciation for yesterday. It was a really fun day. So, I wanted to do two main things over the next few minutes. The first is sort of give you a sense of where this goes, right? One of the things that I picked up from Corey's introduction was this idea that it's a really exciting time to be an educator, because we spend a lot of time, and maybe too much time, thinking about what our students are doing with these tools. But there are incredible opportunities for educators to be using these tools as well, to really build out the next generation of education. And so so this is, work in collaboration with quite a few people, including Corey, colleagues at other institutions, my very supportive colleagues at the University of Illinois. So just to give you a sense of my background here, I have been a sort of programming educator, teaching programming, but also doing it, using the power of computing, which we are so excited to share with our students, but using this myself to build tools, to build courses, to build materials that support my students' learning. And I've done this, I did some analysis of my GitHub commits, and like 4 out of 5 days over the past 10 years, I had some type of commit that I was pushing to one of my repositories. I was a very active software developer. And that's continued in 2026, except for the fact that I have not read, written, or debugged a single line of code over the past 6 months. In all of my projects, including the one I'm going to share with you right now, I've gone into a fully conversational model where I get things done by talking to AI, and I'm going to show you some of the results from that. So you might think of this as sort of a vision of where this goes. So if you start with some of the techniques that have been demonstrated by Corey and others. And I'm actually going to demonstrate that I think some of the advanced agentic techniques aren't necessary. You can do this in a more direct way by just talking to your AI, describing what you want to build. I'll show you an example of kind of the types of things that you can create. And I'm hoping that, together, this allows us again to really build the future of not only, computing education at all of the levels that Corey articulated, but also share these skills and abilities with our colleagues to build better educational futures for our students. So last spring, I guess this spring, I taught a new course on using and understanding AI. And my goal when I started building this course, so I've built infrastructure to support my courses for a long time. My goal with this course was to do this entirely through conversational programming. I wanted to say, I am not going to look at the code. I'm not going to read the code. I'm not going to write any code by hand. I'm not going to debug code in the traditional way. I'm going to do this entirely through collaboration with a coding agent, in this case, Claude. And let's see where that takes us, right? Let's see how far I can get. And I hope that I can demonstrate in the course of one semester, during which, by the way, I was still teaching and modifying and improving my large 400 student CS1 course. I think I was able to do some remarkable things. And I'm sharing these with you because you are too, right? That's the thing that's really exciting about what's happening in technology today. These are things that you can also do to support your students and to support your own courses. So I really try to involve Claude in every phase of the course operations in terms of coming up with content, building out the infrastructure for sure, all the code involved with that. But then also in the in-classroom operations. This was a small course. It was a pilot, so there were 11 students. But one of the things I would say, one of the things we teach our students or try to instill in them, I think in this AI era, is that you're responsible for the artifact, right? So if you use AI to help you build something, you're responsible for how that thing works. And this experience gave me a very visceral sense of that because 2 times a week, I'm up in front of students, not lecturing because I don't do that, but walking them through our activities, presenting the material. And if something's broken or doesn't work or is wrong, they're all looking at me like, why did this thing that you used AI to create not work? And so there were some, dicey moments. There were some exciting times, but in general, that really gave me a strong sense of responsibility for what I was doing, which I think is something that's really important as we show students how to use these tools. So again, this entire, course, all the materials, all the infrastructure was entirely done through this style that I call conversational programming. So no, looking at code, no reading code, no writing code, no debugging based on code, entirely through, hey, Claude, I want to do this thing. It didn't work the way I wanted. There's a problem here. Write more tests to cover this particular case. To try to give you a sense of how that works, I've actually published all of my transcripts that I used, scrubbed appropriately, up on the link that you can see on the slide. And these slides are available on my website, by the way, jeffreychallen.com. So if you go there and click on talks, you can grab this slide deck and all the, the links will work at that point. You can also follow along. And so, I'm trying to pull out, the structure of the course was that we met twice a week. There were 3 types of meetings. We would have, in some meetings, students were using AI to do things. There were meetings where we were trying to provide students with a base level understanding of sort of how AI works, not at a technical level, but more at a conceptual level to help guide their understanding of how to use this effectively. And then there were discussion-based courses where students read and then came into class and engaged with each other. So I'll show a couple of examples of learning tools, interactive examples that I built for students to kick off some of our inductive sessions on understanding AI. So a lot of these would start with students experimenting with something to start sort of getting them curious, having them come up with their own questions, and then we would move into description of sort of how some of this worked at a high level, right? So, and again, this was all built entirely through conversation. So in this case, Claude helped me build like a little digit recognition network. This is a pre-trained small CNN, but you can also train it in the browser if you want to, which is pretty wild. And so, these are the kind of things that I think, again, as educators, we are the people who are going to see all the opportunities to show students how to do things like this, or to create things for our students that allow them to learn better. One of the things I think someone mentioned yesterday during our day zero meeting was that, educators that are now building custom learning, animations for students who are confused about one specific thing. So if somebody comes to you and they say, I don't understand this, you can work with, a coding agent for 20 minutes and produce something for them. And then, of course, you can use that for students that have similar misconceptions in the future, right? So I think this is super exciting. I'll put another one up here, but I'm just going to move on in the interest of time. And, again, I've included some snippets of the logs that were used to create these, just to give you a sense of the fact that this doesn't have to be complicated. It doesn't have to involve, advanced agentic engineering that, Corey is involved with, and he's gone way down that road, right? Which I think is super cool. But I think for people that are just getting started out, just talk to it. Just describe what's wrong, right? So here's an example from, when I was debugging the digit network, right? I'm just explaining like, hey, the thing isn't working the way I want. And that's all the information I need to provide in order to get it to the point where it does work and where students are able to use it. I'm going to skip over some of this, but we also try to involve AI in every component of the course. I noticed, for example, some of my students didn't show up prepared for some of our discussions because either they hadn't done the reading or they had done it, but they didn't understand some of what the key ideas were. This is particularly true when we would read more complicated things, like something by McLuhan, right? We read the bit of Understanding Media. That's a difficult text. And so what I was able to do, again, using this infrastructure purely through conversation with an AI agent, was build a tool that allows students to talk to an agent about the reading before they come to class. This was required for attendance, so that when they show up, they're more ready to talk to a human. And so that was also something that was a real design principle for the course, was that this wasn't a course where I wanted students sucked into their laptops and just being taught by AI. I wanted using AI to facilitate their interaction with other people in the room. And so there was a lot of group work, a lot of sort of students talking to each other, but using AI to facilitate this type of course. Here's another example. So this was kind of a fun one, and this is something that I'm kind of more excited about that came out of the class, which is this tool called conversational assessment. So how do we, evaluate students? We're computing educators. Many of us are familiar with these auto-grading concepts, but in the past, this has been something that's essentially impossible to apply to situations where you don't have the structure that code provides. So again, purely through conversational programming, I had this idea that what could we build a chat-based sort of oral examination style of assessment that students could complete in the browser, where they're talking to an AI agent, and the AI agent is configured to ensure that they are able to demonstrate understanding of a particular concept. So we were able to build this. We actually had students do a bunch of these. And I think this has the promise of bringing the benefits of auto grading, right? Which is collapsing that submit and feedback loop into a much tighter process, so students are able to see their mistakes and learn more. I have this theory that, the value of the feedback that we provide to our students in our courses degrades pretty quickly over time. I think we would all agree it degrades the longer students have to wait for it, but I actually think this curve drops pretty quickly. We gave one of these this semester in our computer-based testing facility at Illinois. There's a link there to provide more information about that. I think this is something that every school should have, so I'm a big advocate of this approach. I'm going to move through some of this. I'm happy to talk about exactly how the tool worked and how we tested it. There's a fun little story in here that I was hoping to have time to share, but I think I'm almost out of time, so that I'll skip over. But one of the things, sort of to point the way to the future, I wanted to share with you is that toward the end of the class, I introduced students to conversational programming. and one of our activities was using a platform built by Replit to produce a website. And then there was a final project in the course where students were allowed to go back to any AI-based project they had done, and they had done things on image generation and building study guides for the courses and all sorts of different things, and just continue that for a few more hours. And every single student chose to go back to building a website using this platform through conversation with AI. And they ended up building some like really remarkable things. And they were really motivated. I mean, I've taught programming for a long time, and the students in this course that did not sign up to take a programming course and had most of them no programming background were very, very just engaged with this content. They got really excited about it. They saw the potential. They were building things that they cared about. It was pretty awesome. And so, I totally agree with some of the comments Leo made about like, this is a new skill. I think the big question that we have to figure out as educators is how is it related to the skills that we've been teaching students for a long time? And my hypothesis here is that, classical programming ability, writing code by hand is related to the ability to work well with AI, but they're not the same. And also, they're not stacked in the sense that you don't have to learn how to write code before you can work with AI. These are the level 1 engineers that Corey's talking about, and that's a good starting point for working with their students early in computing programs. So next semester, we're actually going to double down on this bet and teach an entire course on what I call conversational programming, where students will be building things entirely through, my workflow right now, which is don't look at code, don't look at files, talk to the agent about what you want, understand how to communicate with it about what's wrong, about things that don't work, and just building software that way. This will allow students to iterate more, and I think it'll give them, students with non-technical backgrounds, a lot of actual ability to build things that matter in the world, which is super exciting. So thank you for listening. Thanks to everybody for arranging a great day yesterday. That was super fun. And again, I hope this helps give you a sense of where this goes, what the type of things that you can build to support your students and their learning using AI and using coding agents effectively.
That's awesome. Thank you, Jeffrey. Yeah, so I think Jeffrey just kind of like pushes the point that I was trying to make earlier. That Jeffrey does know how to program, but he's not looking at his code, right? And so this is something that anyone will be able to do increasingly more. If I look 5 years out into the future, my hope is that there's so many people just building the tools that they need to make the world a better place. And yeah, I hope we can just help everyone do that.
Jeffrey sharing a link to his slide. Thank you so much. Jeffrey sharing a link to his slides for folks. Also, just go to Jeffrey's website. There's links to many talks that he's giving slides. He also goes into a lot of detail how these projects have rolled out on his behalf. So someone did ask Jeffrey, if you have a second, how much does this cost for the student or the school? They're curious about the latest project you just shared about just cost. And then wondering also if there's a way you can share how you use Claude and if it was integrated into an LMS or something like that. That might go into some detail on your website, but those two questions did pop up while you were speaking.
Yeah, sure. So the course was small. I was able to gain access to, when we talk about using AI, we're talking about frequently 3 different things. So I pay for my own AI tools. I think they're a fantastic investment. The $100 a month you might pay for access to something like Claude, to me, that is in terms of the learning that my students get out of it, is something that is absolutely worth it. I do think that these tools should be provided to us by our institutions for that same reason. And so please advocate for that so that we start to see that happen more broadly. The AI that students were using, we typically were able to get away with free tiers for things. I mean, we were jumping between a lot of different tools. And so, for an hour-long session during a class, you can usually find something free to use that just gets students started. I do have a contact at Replit, Brandon Middleton, who was really generous and gave us a promo code. So that gave students a little bit more room to work on that platform. As far as the AI that's built into the course, so that's kind of the third usage, that was something that was provided by the university through an API endpoint that basically we set up that goes through Azure and is, for that reason, blessed for some purposes and things like this. But I think getting access to these tools is something that's a real barrier for people, and something that we need to be talking to our administrators about and stuff like that. As far as the usage, so again, if you go to the, and maybe I'll just put a link directly to it, in terms of how I used Claude. I mean, basically the whole transcript is public, right? So this will, if you go to that page, you can see from literally the first, like I started with an empty repo, and sort of from the first conversation I had with Claude all the way till I have to update this sort of manually because there's a scrubbing process. So I think it ends maybe a week or two ago, but it's pretty recent. And so, yeah, you basically see the whole course. And I'm sure there's a lot of semi-embarrassing stuff in there. I'm usually pretty nice to my agents, but I get frustrated sometimes. And there's definitely some mea culpas on my end in terms of places where I made design mistakes that I realized later and stuff like that. But yeah, I mean, I'd like to be transparent about this because I want to demystify the process. And I think I probably fall into the same category that Leo mentioned in terms of like I've done this for a long time. But I don't know. I mean, the other thing that has come out very strongly to me, and I think there's a link to one of my essays on one of the slides, is that I think one of the exciting things about building things this way is that it's a way more fun and it's way less it's just not as unpleasant anymore. I mean, is there anything more dehumanizing than being forced to talk to a machine in its own language? And so for years and years, that was the only way for me to build anything for my students was I had to write the code by hand and suffer through all the compilation errors and the typing issues and the deployment bugs and all sorts of stuff. It was just a really demoralizing, difficult process, which I did because I believed that that technology can improve education, can change education, right? Can support learning. But I think there's a lot of educators that were just like, I don't want to do this. This is awful. I think there's a lot of our students who thought, I don't want to do this. This is awful. Um, and the process of building this stuff through conversation is just so much more healthy from a mental health perspective, in my opinion, than writing code ever was. And so I think we're going to bring a lot of people back, both educators and students who might have taken a CS course being like, I don't like this. This is unpleasant. Maybe they were actually good at it, but they stopped doing it because they just, it's just really frustrating. And now, because they can just do this through conversation, they're going to have a lot more fun with it and they're going to build incredible things. So I hope that that's the case. I certainly have seen the before and after in my own life, which has been kind of remarkable. And so anyway, but yeah, I mean, I do have all this background. So am I applying some of that? Sure, right? But I think it also gives me an advantage point to talk about the differences between the two approaches.
Awesome. We have, I'm sure we could ask the entire group questions all day long. And Leo, you're well, 100% welcome to come back onto the stage if you'd like to just say any final words, anything else you'll want to know. But yeah, we're going to share out, like I said, a lot of slides, links, ways you can join the consortium Slack, and all three of the presenters here have websites where you can kind of learn more just about their approach, some of the essays and talks that they've given, and things like that. We have a couple of really quick questions in the chat here, and then we'll close out with any final words from each of our presenters. I, for one, am just grateful for all three of you coming on here, but it's really great to hear different perspectives on these approaches. And I think that the group is also really, really thankful for that as well. So someone had a question for you, Jeffrey, about the class on conversational programming, and understanding a little bit more about kind of what the objectives are for the student. And I was on your website a little bit, kind of like going through this project. And I know that you mentioned sort of where you want them to think like architects and understand kind of how to build and prototype. I'm thinking that's probably more of what kind of the answer to this question is, but I'm wondering if you have anything else to say about that.
Yeah, we don't know. I mean, I think one of the things that I come into this with is that I don't think we know how to. I don't actually think we know what the basis are of this skill, right? I think it is a skill. I think it's clear. I mean, Leo had some data that pointed to this, that it's not a skill that emerges naturally from training in traditional computer science. I mean, we have senior software developers who are good at it. We have senior software developers who are not good at it. But I think figuring out how to teach it to our students is really important. Until we get there, my position is we should let them do it. For this course, which is a complete prototype, right? The conversational programming thing, I don't know how to do it. I'm definitely coming into it with that level of sort of humility and recognition. I think the things that I think we are going to borrow a lot from more studio art-based design courses, right? Where students are building, getting feedback from other students, engaged in critique. But also this really gives us, I mean, one of the exciting things about these tools is it gives us a chance to talk to students a lot more about what is good about what they've done, not whether the code is good or not. Who cares, right? I mean, Facebook has a fantastic code base, I'm sure, right? I'm sure it's very performant and, embodies best practices in software engineering, but it's a terrible product, right? It's a product that has produced a ton of harm in our society. So I think we need to shift the conversation about what constitutes good software away from design patterns towards, does this do something good for the people that you built it for? Does it solve a real problem? Is it actually going to have a good impact on the people who use it? And so I think those are the kind of conversations that we're going to try to make sure students are having as part of this class, but then also just give them that practice of figuring out, how to, I've got this idea for an app, how do I get it out of my head into the conversation with the agent so that I can realize this vision? And then also, of course, when you start to do that, you realize, oh, geez, something didn't work the way I wanted, or there's this trade-off here I hadn't thought about. So, but this is greenfield, right? I mean, I have no pretension to think that we know anything about how to do this. So the course is going to be definitely an experiment, right? There's a lot of good stuff to draw from those architecture and studio communities that we'll use, but this is probably the most experimental course I think I've ever taught.
Cool. We love experiments. I want to make sure, Leo, if you have any final words to say as well. Some interesting questions in the chat about sort of how we can ensure that things are still secure, right? The security of code and of these products when AI is involved. And I think that's something that even industry is still figuring out, right? So so I don't know that necessarily we have a way to ensure that students have an ironclad approach to that yet. But yes.
Yeah.
Anyway, Leo, anything
yeah.
else you'd like to say or share before we hop off, and then to Corey and then yeah, we'll close our session.
Perfect. I think I really love what Jeff's trying here at UAUC. There are a number of schools I think who are trying similar approaches, and what I like is it's taking us up a level of abstraction, a sense in writing software to say, well, why do you want that product in the first place? It's almost taking that software engineering class, which is meant for juniors and seniors, and now that's the intro class. And so it's a really nice approach. I'm really curious to see what you all produce from it. I did want to offer, and this is maybe an answer to a couple of questions that were in the chat, is we have a challenge as academics, which is our purpose is not to have students necessarily produce software. Our goal is to produce students who learn and know how to produce software, right? And so making sure we still are training students in the skills that matter to them and the skills that matter to us is our core goal. And if they happen to build software along the way, that's great. But that's not necessarily the primary goal of some of the work that we do, which creates a tension because in industry, the goal is the product that's produced. Here we're producing students who are capable. Turn over to Corey, maybe for last thought.
Yeah, so yeah, good.
Yeah, I'm kind of eyeing up some of the questions in the chat. There's a lot of good things to talk about. I think there's a lot of questions that people have around like what are AI best practices? Industry doesn't know what this is yet. Like, how do you make things secure? How do you ensure that like rigor is in place? And those are conversations that we had in the room and we're having in industry as well, and there's a lot of people who are looking for answers around this. I think there's something to be said for where there is a hard question, there is an opportunity. And so maybe the best way to frame it is like, okay, yes, those are real challenges and they need to be solved. And that's an opportunity for someone to jump in and solve it. In one of my blog posts that I outline, I say like level one people need a sandbox, right? Because they don't understand security. And we can't just let them build whatever they want. It's like someone made the analogy to like Roblox, right? Like kids make all kinds of games with Roblox, and we give them like a tool set to build with. Um, and that level three layer's job is to make that tool set for those kids to build games with. And that's kind of where we need to get to, right? This has been the dream of every futurist engineer ever, right? Like Grace Hopper used to talk about how you should be able to just write normal words and produce software. And I think there's like a purist in some of us where we're like, oh, but we're programmers and like programming is the thing. But I think when you have that point of view, you're kind of losing the bigger picture, which is like, no, we are problem solvers, and we just happen to have this tool of programming that helps us solve problems. And reframing things as like, I'm trying to solve problems is where the empowerment is. Getting stuck in the idea that you're a programmer really limits your ability to impact the world and help people.
Yeah, I think that's really true. I mean, Corey and I have talked about this sort of, I think he and I disagree about the existence of a level two, right? Because I think that um, one of the things that's exciting to me is I think within the next few years, if not sooner, we're already seeing this to some degree, but I think we're going to see the emergence of platforms that are built for level one coders, where, I think Replit is a start in this space, right? Where you talk to it, it deploys it for you. And then I think as part of that, you're going to maybe pay a certain amount of dollars, a certain amount per month so that other people can use it. But then there's going to be a lot of security sort of built into that whole system, right? Because of the nature of the people who are building things with it, right? So, there'll be agents, they'll be constantly monitoring things and updating stuff and, closing down attacks and stuff like that, right? So that this is really exciting to see, right? But I think we'll have like this substrate, right? We'll have this place where level one programmers can go to build things. And then those things are maintained over time and made safe and updated and things like that as needed.
Yeah, and I think the real opportunity right now as an educator is like not at that level three. Like one thing that really interested me when we started doing this is like everyone in the room in the workshop was like, we're going to talk about level three because that's like where your comfort zone is, right? It's like it's really easy to be like, how are we going to change CS education for these level three people? But like I would really like to push people to be like, no, like how do you empower level one, right? And a lot of people who are doing CS education now I think they're actually trying to create a lot of those level one people, but level one was always so hard in the past. And level four is going to be very, very important, and level three is going to be very, very important, but we're going to have a lot less of them. So like the opportunity is really at level one, but that's a totally different group of people that have ever been educated to do this work. And they are getting totally different skills, and they're really just using it almost like a lot of people use Excel today, which is like I need to like build something inside my organization, and Excel is the best tool that I have. Well, but that's no longer the case.
I think part of the reason you're seeing that Corey is a lot of educators, I think in CS, we think about our majors. And I think for our majors, we're thinking level three. But I think the real benefit is to the non-majors, to the applied computing majors that Jeff was talking about. I think that's the real potential benefit of these tools is bringing more people into this ecosystem, but that hasn't been our bread and butter for some time. And I'm hoping it becomes that for us soon.
Yeah, I agree. I was out of Berkeley yesterday talking with a couple of the instructors out there, and John De Niro was telling me the story about how, he went in recently to, some of their like HR staff and was like, tell me about the things that you do that are like really tedious and awful. And they were pointing out these parts of their workflows, and he was helping them basically, create, alternatives to doing this using AI, right? That you have to fill out this form that has 50 checkboxes on it that are always checked. Like, here's a way to do it, right? And that's a small example, but I think that there's like bigger examples of this that are going to start to happen where we'll just see people developing a lot more local software, right? A lot more things that are used by small communities of people that solve very specific problems. And it's sort of essentially what Corey said earlier about these, not having to buy these huge, big monolithic tools just because they do one thing that you need done.
I'm gonna cut us off here because I know like I said, we could talk all day. We talked all day on Tuesday. We could talk all day today. We have another session in about 5 minutes. So I do want to thank Corey, Jeffrey, and Leo so much for not only the working group and the work y'all did in the working group, but also for today's conversation. It's a really interesting conversation. It sparks so much conversation in chat. And I think these are the conversations that we were dreaming that we could help facilitate with this summit, and we're really glad that we were able to. So appreciate y'all so much. Evnie, I know is popped on. Did you want to say something?
Can I? All right, can you all hear me okay? Sorry, it's all the joys of being virtual. So I'm gonna flip over to something logistics. Okay. So I know I'm working on making sure the team is working behind the scenes to make sure people have access to Copilot Pro. The 5 people I just posted in the meeting chat should now have access. Please let me know if you don't. If you are not on this list and do not see Pro when you go to your settings page in GitHub, please let me know, and let me know by sending your GitHub handle here, because that's the fastest way that we can get you access. Want to make sure everyone has Pro as we go into the hands-on sessions. Okay, yeah, thank you, everyone. We'll pause for a couple of minutes. Okay, yeah, until we start. I see a note here. This was amongst the best sessions I have attended. So thank you. Y'all are so inspiring. Thank you, Corey, Leo, Jeffrey. So great.
Thanks again to everyone for putting on the workshop. It's a lot of fun.
Thank you,
Great,
everyone.
thank you.
Audio back here.
Oh, my speakers. Now you.
Thank you. Okay, just to let y'all know, taking Corey out. So yes, we will start back up again with Swift from Major League Hacking in 5 minutes. So we give 5 minutes for everyone to get up, get some water, and we will dive back in. But thank you all again so much in the chat and for attending this awesome session and for the conversation. I hope it was really thought-provoking and interesting, and most of you wanted to give you all a sense of what else is going on out there and what kind of experiments other educators are doing. And yeah, awesome. So excited. All right. See y'all in a few minutes. Thanks. Okay. We are going to get started with our next session. And I'm going to bring Swift on to the stage. He's going to be leading our session. Swift is the founder and CEO of Major League Hacking. Swift is the best. GitHub Education has worked with MLH for over a decade. I know he'll say a little bit more about our partnership. So excited for today's session, Swift. Anything you'd like to share as level setting? I will back out of the way and I'll just be managing your screens here to make sure everything runs smoothly. But we're excited to have you here today.
You're all good, Morgan. First of all, thank you for having me. I just caught the tail end of that conversation right before mine, and like, holy cow, that's amazing. I wish I would have been here all day listening to some of that discussion. I also saw a lot of frustration in the chat from people who are feeling the same thing I'm feeling, and I'm sure the same thing that all the people on the panel are feeling, which is that this is a moving target, and we're all figuring out exactly what AI means for ourselves, for our students, to exist as humans. And hopefully over the next couple of minutes, I'm going to give everybody some practical tools to be able to actually talk about these skills, both for themselves and for the people that they empower daily. But I'm very excited to be here. The only thing I wanted to double check is that I can do my screen share here. I have not been in Teams. Of course, I may have to rejoin Teams here, so I may need you to be my filler for a second.
That's totally fine. It happens.
Class,
Teams happens to the best of us.
It does. Right. I will be right back.
No worries. We'll see you in a second. Okay. I think I'm just gonna pop into any Q&A. Paul says, will recordings of the session be made available? Yes, recordings of all sessions will be made available after we are done. If you came 15 minutes late, missed the first 15 minutes, we went for longer than we would have normally, but so you'll get a lot out of it. You still got a lot out of it, even if you missed the first few minutes. But we have links to everything Leo shared with me, his slides as well. So we'll have slides and Corey, Jeffrey, and Leo's respective websites that they are representing the consortium, as well as Corey and Jeffrey's personal websites. They have more information about the projects that they described, as well as all of their approach and things like that, and examples. And then we will have the actual recordings as well. So let me make sure that Swift is able to rejoin and that we're able to get him back in. And that's us. Yeah. There he is. All right, it's back in. There he is.
I think I'm back.
Back in. Awesome.
All right. Sorry for that. A couple technical difficulties here. No big deal, though. All right. And I'm going to share my screen here. I've got some slides, and then we're going to get hands-on.
Okay, awesome. I'll leave you to it.
Thank you, Morgan. Hello, everybody. I'm Swift. I'm the CEO and co-founder of Major League Hacking. If you haven't heard of Major League Hacking before, I would encourage you to ask your students, especially if you teach computer science. We power the largest community of hands-on software creators in the world. About a third of computer science graduates each year in the United States and many other countries around the world go through one of our hands-on learning programs, which I'll tell you all about in a few minutes. But I want to start by telling you a little bit about my story, because I think the story that I had getting into tech almost 20 years ago is actually going to be incredibly representative of the story that we're going to hear from countless students and faculty members over the next several decades. I actually did not start out wanting to be a technologist at all. My parents are the kind of people who believed in degrees with careers attached to them. So doctor, lawyer, accountant were my three choices. When I went off to university, I decided I was going to be a lawyer. And while I had an interest in technology, it was certainly nothing that had triggered, anything on my career radar. And I was literally getting ready to apply for law school when a friend found out that I was interested in tech and invited me to my first hackathon. Now, I'd never heard of a hackathon before, but it sounded like something that elite programmers did, not some complete beginner who wanted to be a lawyer and not a software engineer anyway. But thanks to some encouragement from my friend, I went up to NYU, about an hour away from where I went to school, and spent my weekend building. I came up with an idea for an app, and I literally brought it to life over the course of 24 hours. And I learned more in one weekend than I had in literally my entire career up to that point. And I remember the next day after I, of course, fell asleep from being up all night and working on this project, but I looked myself in the mirror and I said, that was the greatest experience of my life. I've got to be a software engineer, forget about being a lawyer. So I did the thing that felt really natural. And this is, I think, where you all come in as educators, is I decided to go back to undergraduate and get a degree in computer science. And I showed up to these computer science classes and was frankly shocked by how unlike a hackathon they actually were. Frankly, it was, a lot of theory. The technology was already 10 years out of date. It was a solo sport. And honestly, it was kind of boring, if I'm really being candid about it. And I did the only thing I could. I took my education into my own hands and supplemented all the things I was getting in class with literally learning by doing, going to hackathons, learning to contribute to open source, eventually working my way up to an internship. And all of these things involved actually using the code and tools that mattered outside the classroom. And I learned a really important lesson, which is whether it's day 0 for you and you're a student like I was, or it's day 10,000 and you're literally trying to keep pace with this stuff that is changing by the minute today, we all need a space that's not class, that's not work, where we can get hands-on with the code, the tools, the technologies that actually matter, and build our track record and competence and network and the things that support us on that journey. And so I founded Major League Hacking after I graduated to democratize access to hands-on technical education. Today, about 10% of all of the software engineers globally have been through one of MLH's programs and have accounts or memberships with us. We do hackathons, content, corporate trainings, workshops, internships, all kinds of things, all united again by this idea of hands-on keyboard, learn by doing. And on the student side of things, we started on university campuses. I mentioned already that about a third of computer science grads each year go through one of our on-campus programs. And we're doing around 1,500 hackathons a year with amazing partners like GitHub. And this is more than just an event. This is a place that your students find belonging, where they feel like they actually are seen and are gaining real skills. And often it's what's supplementing their in-classroom learning and allowing them to actually go out and enter industry successfully. Now, we're all here to talk about AI and how it's changing not only the world around us, but especially computer science education. And one of the main things that we've been thinking a lot about at Major League Hacking for more than a decade at this point, but we're seeing a dramatic acceleration of, is that software and coding and the idea of using technology to solve problems is becoming accessible not just to the 40 million software engineers we have in the world, but literally to more than 1 billion knowledge workers who are now coming online, able to create amazing digital artifacts using tools like Copilot. And my goal today is to give you an introductory crash course in how we at Major League Hacking are teaching these things, and to give you some practical tools, both in terms of how you can bring this into your own classrooms, as well as how you can be talking about it with your students or thinking about it, mental model for yourself. Now, one of the places I want to start is the analogy that I have been using most prominently when I'm talking to people about what is happening with AI when it comes to software. And specifically what I keep saying is that software is having its iPhone moment. Now, before the iPhone came out, humans took something like 85 billion photos a year. Photography was this incredibly specialized skill set. You needed expensive equipment, you needed years of experience, you needed access to specialized locations like dark rooms. It was time and money intensive to be able to be a photographer before the iPhone. Today, post-iPhone, we take 2.1 trillion photos a year as a society. That's 25 times more than we were taking before the iPhone came out. And are there still photographers today? Absolutely. But are there way more people like me who are using my phone to capture 10 photos a day of my daughter and use that as a tool, a moment in time, a preservation of something I want to look back on and remember? Absolutely. Would I ever call myself a photographer? No. But do I probably take more photos over the course of my life than the average photographer did before the iPhone? Absolutely. The skill that photography became is a commoditized skill where literally it's just part of everything we do. Nobody thinks about pulling their phone out of their pocket and taking a picture and using that as a utility in their life. Would you, turn around that and turn that into a career? Probably not, without some, training and excitement and enthusiasm around it. But the point being that our relationship with photos as society changed dramatically. The same thing is happening with code. The type of software that you and I are used to interacting with, this high production, high scale, high visibility software, is not the majority of software that will be written in the future. While that will still always be important, and it'll be the things that we look to. And in the same, going back to our photography analogy, like if I was getting married, would I hire a real photographer and create this, high production artifact for my wedding? Absolutely. But more software is going to be written by people like you and your students that serves a utility, a moment in time. It's going to be hyper disposable, hyper personalized, and there's not going to be anything like technical debt, because we're just going to throw away that code and rewrite it when we're ready for it. Now, if you are like me and believe in this future and are seeing this happening both in your classroom and in the workplace, the next thing to realize is that the vast majority of the market for this just does not exist today. There are literally only 40 million at most software engineers in the entire world who are professionally employed to write code. There are literally 1 billion people who suddenly have this ability to create these software artifacts, but most people aren't doing it. If you're in an event like this and you're using AI as part of your classroom and education experience on a daily basis, you are literally in the 0.01% of early adopters. And I know that when we look at social media, the Twitterverse and all these things, or if you live like I do in New York or out in the Valley, you might feel the opposite, like you're so far behind and that you don't know enough. But the reality is this is literally the greatest workforce management, change management issue that humans have ever seen. And it's happening in a way that none of us can ever really fathom or reason about, because it's never happened before. For all of history, technology has been adopted in a pyramid shape from the top down. Government, big business, consumers. Think about the internet, right? Literally started as a project for government agencies to be able to share data and communicate effectively. Today, we literally all walk around with mobile phones in our pocket. It took decades for that to play out, and a tremendous amount of change management in society. Now, AI is the first technology where that pyramid has literally fully inverted, right? So consumers, who implicitly are our students or people out in the workforce, they are adopting this technology faster than the businesses and the governments that they are employed by or are supported by. And that's going to be true in your classroom as well. So keeping that in mind, literally, there is almost no way that our institutions, our curriculum, our pedagogy can keep pace with how fast the people who are actually using this stuff are adopting it. And so we need new educational methods in order to actually keep pace with this change and to prepare our next generation and our current generation of workers with the specific skills they need in AI. Now, my thesis, which I'm going to spoil my thesis here early on in the talk, is that the best possible mechanism for this right now is what's called a hackathon. And my goal today is to not only give you these tools to be able to talk about it, but to hopefully convince you that actually bringing hackathons into your classroom setting, using them for yourself, as well as for your students, is actually a much more approachable method than you probably realize. And it's a way to actually make sure that they have these skills in a responsible and meaningful way where they can actually draw value from them right away. Now, before we get into actually how to do that, I want to talk a little bit about where most people are on this AI adoption curve. I have a 5-point hierarchy that I like to think about in terms of where people are in their AI journey. It starts on the far left with AI curious, and it goes on the far right to AI native. Now, AI curious, which is where the vast majority of people who are using AI today are, they actually use AI more like an advanced Google search than like a thought partner or a peer or a member of their team. If you find yourself going to ChatGPT or to Gemini and typing in a question to get back an answer rather than going out and finding that answer yourself, that is the defining activity of somebody who is AI curious, right? Like they're treating it like this answer engine where they can ask a question and get answer back. The core skill that somebody learns and that foundational layer with AI is the idea of prompting. Now, I love the analogy of Google search here because, again, this is one of those things that on its surface feels very simple, but when you really get into it is very advanced. All of us probably can relate to going into Google, typing something in and finding a result. That is the most fundamentally basic way to use Google, a search engine, to find answers. When you meet people who really understand how to use Google search, they're doing all kinds of things like adding fancy keywords and filters and segmenting to sites or sorting the results. And it's like a superpower that is nothing like the type of basic Google search you can type in. And so in a similar way here, most of your students and most of you, I would guess, are actually using this pattern based on our familiar experience of understanding search, but we haven't yet gotten to the point where we become power users or able to use this. Now, step 2 is when you start using AI as the thought partner. And this, I think, is actually, if I was all of you, where I would be focusing on getting my students first, because odds are most of them have not actually crossed this chasm into treating AI in a different mechanism than they are used to with like traditional tools that are available to them today. The way that I would encourage you to think about this is that thinking with AI is actually about workflows. It's about understanding how we make decisions, how we come up with ideas, and how we actually produce things, and integrating AI into that actual experience to help us extend and further what we're able to do. Now, stage 3, which I think maybe by the end of today, I'll be able to get some of you to, is what I call a builder. The defining act of a builder using AI is that they're actually creating tangible artifacts with AI. In most cases, this is going to be code. So when you think about something like vibe coding, where you're literally working with an agent to produce a website or an app, that is probably the most common way. But there are other types of things you can build with AI too. It could be a slide deck, an image, a video, any tangible digital artifact that you are reusing that has value, not only for solving a problem in a moment in time, but potentially in the future. That is the type of artifact that a builder is most reliably creating. And they are using AI to create these reusable experiences. And I'm going to show you a little bit of that today. The last 2 I'm not going to spend a lot of time on, but the key defining features of this is that AI becomes an extension of you beyond your the context of your in-person, in-the-moment experience. So what I mean by that is people who are deploying agents, which are always on, that they're interfacing with the same way they would interface with another human, delegating work to those agents and having them actually respond back. That's a signal for somebody who's moving into the operator or partner stage. And then finally, when you get to native, I think the defining characteristic of this is that it becomes a default tool in our head that we start rationalizing about how we solve problems with from the beginning. So in the same way that if I gave you a challenge today about something you didn't know, you would probably go to the internet and use that as a tool for researching and understanding. The internet has just become a part of the fabric of how you actually make actions and do decisions. The same thing will happen with AI, and that is the defining characteristic of somebody who's AI native, is that literally the entire corpus of their decision making and thought process revolves around this. So knowing that this is the hierarchy that we're working towards, knowing that most people are on that far end of curious, and we want to get them at least to step 2 or 3 on this, how do we actually do that? Well, I think one of the key pieces that people have to understand here, which is so radically different than where we were before the age of AI, is this. Effectively, what's happening is the cost of writing software or code is going to 0. Tools like GitHub Copilot have literally democratized access so that anybody has the ability to produce software. Effectively, the only limiting factor is literally your ideas and your ability to put hands on keyboard. So the things that matter in an environment where the cost of writing code goes to 0 are 3 things. It's ideas, it's taste, and it's distribution. It is what's the problem we're solving? What does good actually look like? And how do we get it into the hands of the people that we're trying to serve? Now, I'm going to answer that question in the context of classroom, and I think that literally the people on this call are the world's leading experts in their ability to write this kind of software. Not only do you know the problems that you and your students encounter every day, but you know what good looks like. You literally are educators who are responsible for helping people go on this journey. So you have baked in taste that somebody outside the education system will never have. And you have the distribution, whether you're making something for yourself with a distribution of 1, for your peers, other faculty members who literally are working on navigating the same challenges you are, or your students who are looking to you for solutions. You have an audience that you can use to actually get these tools and technologies and the solutions that you build out into their hands right away. So what I would say to all of you is that you have a superpower, and our job is literally to tighten this loop to be as short and sweet as possible. Now, the best way to do this, and as I said, my core thesis is that hackathons are literally the perfect invention for this. Now, hackathons, you might be saying, isn't that just a developer thing? And maybe we are here talking about computer science education broadly, but the reality is that hackathons today are more accessible than ever to non-developers or folks who would call themselves maybe AI curious. Literally, you can do things like writing prompts, talking to users, sketching interfaces. All of these things build context, which we're going to talk about a lot today, which are literally the most important piece of writing software. So what exactly is a hackathon, though, and why are they suddenly so much more accessible? Well, there's a couple of things. One, hackathons are about creating unique, creative solutions. If I literally had you all sit down and we were all making exactly the same thing following a tutorial, that's not a hackathon. That's effectively spec work. The open-endedness and the creativity is the first element. The second element is it's time bound, right? Usually between 2 and 36 hours long. If you're integrating into a classroom, you could do this as an hour session very easily, especially if you're building on them over the course of several weeks. But the key piece is that it ends. There's a deadline. And that deadline both is a constraining element, but also an empowering element of that it forces you to make shorter term decisions than you would in order to get to a solution. They're implicitly collaborative or multiplayer. We all know the value of project-based learning and actually getting students to work with each other. Hackathons are usually a team sport, anywhere between 2 and 4 people working together. The key output is actually making something. So not only do we have to come up with the idea for a solution, but we literally have to make a digital artifact. Again, in our skill hierarchy, making sure that everybody is ending up in that creator middle ground. And then everybody shows off what they made. As somebody who has firsthand experience of understanding how reinforcing my own learning is often done through teaching, we can empower our students with that same exact experience where we can literally have them demo to their peers what they created, what they did, what they learned, not only to synthesize those learnings themselves, but also to create good models for the people around them to understand that everybody's on this journey together. And even the most advanced, users of AI or the most advanced students in the class may not actually be that far ahead of them in terms of the adoption of some of these technologies. Hackathons are an incredibly powerful tool for a lot of different things. To give you a really tangible example, the second hackathon I ever did when I first got my start was actually a writing hackathon, where we showed up in a room and we all spent the day writing poetry and short stories. The mentors were experienced editors and authors walking around and helping people. Obviously, you can do hackathons with code. You can do learning hackathons focused on synthesizing information about a topic or a skill. They're great for group presentations, for exploring data and resources, for prototyping digital experiences, and just rainy day projects and ideas that otherwise would never see the light of day, but are really powerful for teaching skills. So I'm going to get into doing some demos in a few minutes here, but I want to give you all some guidance around what I'm doing and how you should be thinking about it. So while we're not all in person today, I know that over the course of this event, there's some open-ended space for you to literally open up some of these tools and actually try them and use them and collaborate with each other. While I'm doing these demos on GitHub Copilot, I would encourage you to follow along. Every one of these is going to be ideally approachable and in a way that you can, you literally bring back and use for your students as you teach them. I want to emphasize, I'm keeping an eye on the chat. I know that the GitHub team is as well, but if you do have questions or there's anything confusing, literally drop a comment in the chat and I will double click on it. There are no wrong answers. There's no stupid questions. There's no bad ideas. We are literally all learning this stuff as we go. And I just want to encourage positive thinking both for yourself as well as for the people that you might talk to about this stuff. And the number one thing that I think most people need, having taught literally hundreds and hundreds of thousands of students these skills, is they push in the right direction, a word of encouragement, somebody who's saying, you can do it, just keep trying. And often that's the difference between a student who succeeds in building something and learning something new and one who fails and gives up along the way. So let's get into some definitions of the things we're going to see today and that I'm going to start demoing for you. The first one I want to talk about is the difference between a prompt and an agent. Now, I know that there's a ton of different competing definitions of this. My definitions are not the same as everybody else's, and I'm giving you these definitions now so that as I'm saying these words, you understand what I'm talking about. When I say a prompt, what that usually means is a one-shot instruction. Ask a question, get an answer. It is literally the content that I am giving to the LLM or the AI in natural English language. It's a fresh context every time. If you think about the ephemerality of chat, when I open a new chat window, there's no history. A prompt is based on what is literally visible on the screen and what everybody knows. It's usually a single thread. It's usually responded in real time, and it lives and dies in the chat. When I close the chat, it's over and it doesn't matter. Agents, when I talk about them, or workflow, or agentic workflows, which I'll often say as well, because there's a lot of similarities between them, is a saved workflow with a job description. Meaning when I use this AI, or this workflow, this agent, it is solving a specific problem through a process. The context is preloaded. We literally we'll talk about the importance of this, but we'll have artifacts that we're plugging in. It's typically multi-step, meaning it's doing a series of things and following instructions, and it lives somewhere that we can reuse it. So rather than the ephemerality of chat, which when we close the window disappears, an agent or a workflow we're saving and reusing. Now, literally, again, I probably don't need to keep credentialing myself, but this is something I thought was really interesting. So Major League Hacking and GitHub have been working together now for coming up on 13 years this summer. And we, as you could probably imagine, many students, their first exposure to github.com is through a hackathon with Major League Hacking. Well, we've been teaching Intro to Copilot workshops for literally the last several years. And I could say that about almost 50% of developers in MLH's audience, which again includes about a third of computer science grads, this is like most of our computer science students, especially here in the United States, they're using GitHub Copilot for the first time at an MLH hackathon. And it's an incredibly empowering and unlocking experience. But the thing I want to emphasize here is that while, again, this might feel like a ubiquitous technology, most people have not touched these things and probably don't know what Copilot is or why it's useful or how. And so part of our jobs as educators and part of my job at Major League Hacking as a partner of GitHub is constantly reframing to everybody what Copilot is and why it's valuable. So, well, I'm sure you've heard Copilot a million times today. I want to go back to that. The first thing I want to say about Copilot, and especially Copilot Web, which is where we're going to spend the vast majority of our time today, is that it is literally the fastest way to put these new AI skills into practice for most people. Opening up copilot.github.com is literally a starting point that I would send any student to literally every time that they are starting to think about solving any kind of agentic problem. Copilot is the best balance, especially on the web, is the best balance of functionality and user friendliness. My next slide that I have is actually going to help you understand what some of the different Copilot features are that we're going to be using today. But the key thing to keep in mind is that if we just treat copilot.github.com as our landing page, that is a great starting point for almost anything we want to do. And it does not require an immense amount of developer experience or friendly, and is incredibly user-friendly to get going. So the killer slide, which is this one, this is a breakdown of the 5-ish, and there's more than this, but the 5-ish most important Copilot features that we're going to be focusing on today. The first one is Copilot Chat, the web interface. It's going to look like any chatbot that you've ever interfaced it with. It's fast, it's browser-based, it's literally on github.com. We can go in, we can ask a throwaway question, we can give it context of repositories or other documents, but it's literally just like a chat-based coding agent in the browser. Copilot Spaces, which is an incredibly powerful tool that I'm going to show you how to use in detail today, is one of the most valuable experiences for grounding your Copilot responses in specific documents or context that you want. We're actually going to use it to demonstrate how we can make a bot that has specific Q&A around a course that we're teaching. GitHub Spark, which is a relatively new feature of Copilot. It's a tool that allows you to build and deploy full stack web applications using just a prompt. So if you're familiar with tools like Lovable or Replit or something like that, Spark is a really good parallel to those. It's literally baked into the GitHub ecosystem. We're going to make something cool with it today. Web agents, this is the most difficult in terms of skill, but it's also quite powerful. This is literally delegating engineering work to Copilot from any github.com page. So we could have it literally do coding work in a repository, open pull requests, and act as a fully autonomous developer, however we're triggering it from the browser. So we're not installing custom software on our machine necessarily. And then last, which is how most developers are probably interfacing with Copilot, but is probably the most difficult, but it comes with the most power, is using Copilot as part of their terminal experience or their IDE experience, most commonly in Visual Studio Code or VS Code, if you're familiar with it. We're not going to touch on this today at all because, frankly, again, while I think it's an incredibly valuable tool for a computer scientist who's learning how to work in IDE, for you as educators and when we're thinking about fundamental skills, I think you can go a long way with just the 4 web-based activities today, and we'll be able to teach ourselves as well as our students specific practical AI skills that they will help them not only in your own classes but beyond. So I'm going to fire up Copilot here in a second, but I just want to give 5 really quick power user tips that I'm going to be doing throughout the course of this session, and I want you to watch for them as I do them and try to call them out. The first one is decomposing big prompts into smaller prompts. If you think about LLMs, they are literally an average machine. If I give you a character A, they output the most likely next character B. If I want to get an above average response, how do I do that? Well, if I put in an above average input, I'm going to get the average response for that above average input. So when we think about that, prompting is literally the single highest variable interface for anybody's success when they're interfacing with AI. So doing things that make those prompts better is implicitly like the most important thing. So the first one is, if we have a big task and we're just asking the AI to do everything, it's going to get confused. It's going to go all over the place. And specificity and small tasks are much more approachable. So teaching your students, this is like that classic computer science exercise of having somebody explain how to make a peanut butter and jelly sandwich and then having to break down every step in between. It's the same idea here. We're literally thinking about how do we enable our students to take the big picture prompt, what they want to accomplish, and decompose it into smaller steps that they can follow. The second thing I'll say is that literally, again, which is what I said before, is that these are just average machines. So if we want to get above average results, we need to use above average inputs. Frequently you will see, and you will see me do this, people will start their prompts, "You are an expert in." And the reason that they do that is because it anchors the LLM in the specific average inputs or tokens for that context. So when we will do this around prompting design and how I actually do that in a second, but framing for the LLM what its job and role and context and experience are is a really great shortcut way to get to, again, this above average input, which is what we're chasing. The third tip, which is if you're just going to take one thing from this entire session and just do it, this is literally the most important tip, which is use the AI to generate your prompts. Again, if we're coming back to this idea that prompts are the highest variable input, and that, again, if we can increase their quality, we're more likely to get better results. Literally asking the LLM to create the prompt for you with the specific context and expertise you're looking for is a shortcut way to make sure that you're getting great outputs, better inputs, better outputs. And literally, if you just do this one thing, this will take your AI usage and transform it exponentially if you're not doing it already. Tip 4 is around how we actually execute problems. Most people, when they work with AI, they think about it as a very short linear chain. I have an idea, I tell the LLM to do it, and then it's done, and I look at it. That's actually a terrible way to use AI because, again, it's that's the lack of specificity, and unless we're really detailed and really precise about what we want, there's a lot of variance that happens across like a wide spectrum of random events. And so if you think about a better pattern for working with AI, it actually probably looks something more like this, where we have an idea, we're doing a bunch of background research, where we're effectively developing the spec of the document of what we want, and then we're going through a loop where we're literally iterating against that plan until we get to something that is actually good enough to deploy. So rather than thinking about one-shotting, I give it a prompt, I get a result, and I put publish and it's done, working with AI is actually much less linear and much more like a loop and requires iteration. And again, for programmers, that's a pretty natural thing because that's how we've worked for the last 30, 40 years. But for a non-programming student, or for an educator from another discipline, this might not be an obvious loop that they need to. So this coming back to this natural debugging iterative loop is the key. And the last tip, which again, you're going to see me do a lot of this, is about creating reusable context files. When you hear things like skills or agents or prompts, like often what people are saying is that they have found a single piece of text that they can give to an LLM that is generally really powerful and reusable. My best advice to you is literally create a GitHub repository today and start saving prompts in it and reusing them. If all you do is that, and my tip around using AI to generate those prompts in the first place, you will go from using AI as this kind of natural like search replacement to something that's a lot more powerful and customizable. So here are all 5 of those tips again on the screen. I'm going to demo a lot of these to you as we go, but start small, chain your steps together. Start with a persona, giving the LLM actually guidance around what it's trying to do. Make the AI actually write the prompt in the first place. Use an iterative loop as we're building things, and then create reusable context files. So with that, I'm going to just start sharing a different part of my screen. So let me actually stop this. And I'm going to share, let's see, my entire screen here. And we'll pull that on. All right. Let me get rid of this and that. Okay, so let's see here. Okay, let me just move my controls. All right. So the first thing we're going to do is we're actually going to open up Copilot and talk about it. Again, I'm going to be focused on Copilot Web So the URL here, if you're following along at home, is copilot.github.com. When you open this, it's going to redirect you to github.com/copilot, but this is going to look a lot like a chat interface that you're probably familiar with if you've ever used another chatbot for something with AI. Now, a couple of things I'll call out here. We have this text box. We can ask it basic questions like, what is the weather in NYC today? And we get an interface here. We'll do a little thinking. We can see which model we're using down here. I will talk a little bit about models, but for the most part during this workshop, I'd actually encourage you to ignore that. We can see what Copilot's doing. It's actually using a tool, so a web search on Bing, to look up the actual weather in New York City. We got a little background here. Nothing super special about that. Literally just normal kind of chat interface. We do have. I want to illustrate again the idea of context, which we're going to come back to a lot today. Context again just means anything that is in the existing chat that the agent has reference to. So it's like, what does it know? So you can imagine here as an example that because I've asked a question about the weather in NYC, the agent has some context about where I am and what I want to do. So when I say something like, what should I do today? We can assume that the agent is going to use the existing context, which is me asking a question about the weather in New York, and make an assumption about New York City and the fact that I'm in here. So if you look, these are all specifically responses that are scoped based on that context that exists in the chat. Now, if we literally take this same chat and we're just going to make a new, chat, there's this handy little new chat button over here, and we just do that same thing, it's not going to have the context about me being in New York City, and so the recommendations we're going to get are going to be completely different and not grounded in that same thing. So first lesson again is it's really important to think about what's in the context. What does the agent know? Again, context, while it sounds like a scary word, all it is literally the documents or the chats or the history of our interactions with the agent. As long as we are really thoughtful about what the agent has, that's going to yield our best results. So what are great inputs, and what information does the agent actually have so far? Now, if we go back to the main interface, there's a couple other things I just want to call out here. First one are these buttons down here. The first one on the left is the toggle mode between ask and agent. Ask is what we've been demonstrating so far. Again, a chat-based input-output call and response type interaction. Agent is a much more autonomous interaction form, and we'll talk about it in a bit, and it will appear in this agents tab. But when we want to delegate to an AI to go out and do something in one of our repositories, we're going to use the agent mode. We're just asking questions, and we're expecting instantaneous response in the same immediate kind of context of our minds and like what we're talking about. We're going to be using the ask mode. You can also scope in repositories, so what tools or code bases or documentation that the LLM will have access to. We're going to talk a lot more about that as we go. And then if you want to add other things like spaces, which we'll talk about today, or files from your computer as context, you can do that with that little plus button. You can change the specific models depending on which plan of Copilot you're on. You'll get different options. Again, I'm not going to worry too much about that today. I'm just going to pick fast and cheap models when I have the chance, just because this is a live demo and I don't want you to spend a ton of time waiting. Now, I want to dig in a little bit more on the context idea and how we can get better results by doing some basic prompting. One of my favorite exercises here is to actually build a workflow. So this is going to be a reusable prompt that does some tweeting for me, Mike Swift, the CEO of Major League Hacking, about this event. So let's start with zero context whatsoever. And we're going to prompt our Copilot agent here to draft a single tweet for Mike Swift about attending the GitHub EDU summit today.
Swift, can you zoom in a little bit?
I can, absolutely.
Thank you.
Thank you, Morgan. Actually, I should pull the chat over to the side here as well so I can see that. It's not going to let me do that. All right, well, Morgan, you'll just keep me honest. If anything comes up in the chat, just let me know. So if we hit go on this, we'll see what Copilot does. But we can expect that there's no context in here. It's going to use whatever training data it has. It doesn't know anything about the event yet. We have what effectively is a very generic tweet, and probably something I would never actually say or do. So how can we make this better? Well, the first thing we should think about is context. So what is the context in the task that we're trying to do here today? Well, our task is we're drafting tweets for somebody named Mike Swift, and we're drafting it about a specific event. Let's start with Mike Swift and a voice. So let's say that we wanted to actually, create a context file around this. So we might say something like, you're an expert. So remembering again that we're grounding the AI in the role and what it's doing. So let's call it like prompt engineer, because we're going to be generating prompt. And your task is to write a system prompt, and all system prompt means is just fancy word for the background context that the agent has, for an AI that drafts content in the voice of Mike Swift from Major League Hacking. So again, a couple of things we're modeling here. One, we've grounded the AI in a specific role that it's acting in. So again, above average inputs, above average outputs. We've told it that it is a prompt engineering expert, so it knows that the output that it's going to use those best practices. And we've given it a specific task, which is to write a prompt about as if for an agent that will tweet as if it is Mike Swift. You can see that it actually did some background research on me with Bing, looking up my style and on blog posts. Again, this is the type of context that it's building here to actually help the agent get a better answer. And then it's generated a prompt in what I know as an expert is a specific prompt engineering framework. Now, the reason that this prompt is really good is I'll just kind of go through it again, just to help you understand. There's a very clear role, what the agent is actually doing. There's a scannable list of priorities and how the agent should be thinking about making decisions. There's guidelines around specific output structures, what it's looking for. It has some specific kind of guidance around tone and vocabulary and things like that. And then it has examples in it, right? So it gives a generic corporate version and then a Mike Swift, version. So this is a generally good prompt. We can play with this a little bit. If we go back to our new chat window here, and we're going to make some changes to this. So I've just pasted in the prompt it gave it. I'm just removing the extra little flares that the AI put in it in the chat. And we're going to try the same experiment. So write or what did I say? Oh no. Live demos. Sorry about that, friends. Hit backspace too many times. There we go. All right, so we'll draft a tweet for Mike Swift about presenting at the GitHub Education Summit today. So this time, again, the agent has new context. So we've written a reusable context file that we can now give to Copilot that literally will give us better results because of what the agent actually has. So increase the quality of our inputs. Now we have something here that's actually sounds a lot more like what I would do. It gave me more than one option, but these all seem to have a lot more of my voice in them and are actually things I would probably tweet. The thing it's missing is any context about what this event is. So again, how can we fix that? Well, we can create another reusable context file. And I was actually smart on this one and created a context file in advance here that I'll pull up. But if I go, let's see, right here. So I actually have a little session overview of what I'm doing here. And if I go back to my chat, I'm going to grab this again so that we don't have to repaste it again. And we'll paste that in. And then we're going to, again, add from our computer a file. And I just had found that one, so we're going to grab that right here. So now we have, again, background about Mike Swift. We have background about the session. If we do the exercise one more time, draft a tweet for Mike Swift about presenting at the GitHub Edu Summit today. This time, without ever having changed the model, all we did was literally change the context and the inputs. We can now get a much more tailored tweet that is actually something I would send about the specific event in my voice. So again, I just want to come back to some of those tips that I was talking about at the beginning before we move on to more advanced things. The key pieces here are we've broken down a task, which is creating a workflow for a ghostwriter to write tweets for me into a bunch of composable tasks around my biography, around the actual event itself, and the context files that we needed. we use the language of an expert to generate a prompt that specifically does things in my voice. And we actually tested that iteratively, where we went through the loop several times on the journey to be here. Now, if I wanted to save these things, again, my best advice to you is put these in a GitHub repo where you can reuse them, or you can do the next thing we're going to do, which is to use a GitHub Copilot space. Now, spaces, which if you remember that slide I had up before, these are reusable sets of context and information for Copilot to use. So we're going to create a space here, and we'll call this GitHub EDU Summit. I'm just going to do it under my account for now. But the things you're going to notice here are in this interface are two things. One, you have the normal chat that we just experienced and saw before. But two, you have two new boxes here for content and instructions that we can use to basically create that reusable workflow that we just did. So as an example, in our instructions, this is a place where we would put in our system prompt for tweeting in my voice. This is too long, so we're going to cut some of it, which we're going to get rid of. Oh, what are we going to get rid of? We're going to get rid of some of this stuff down here. Get rid of that. Okay, great. So we have our system prompt. The next thing we can do too is add other sources. So this is really cool because it's natively integrated into GitHub as well as the stuff that you can add for your computer. But for example, if I wanted to add a repository, I could add, I've got a collection of prompts that I use for different tasks like that called MechaSwift. I can attach that. If I made a specific repo for today, like the GitHub EDU Summit, this is just an empty repository, but just as an example, I could attach a repo and things in it, and then I can ask questions about that. Or I could add another file, which, again, we saw this before, but I could add the information about my session, which is now in there. And now when I ask these things, I say draft a tweet about the EDU Summit for Swift. Rather than having to paste in that context and manage it, it's baked in from the default. So we can see how it literally is within this GitHub EDU Summit project that I created, or space that I created. And we have a chat that literally has that context preloaded into it. So we can see how that actually did the same thing. Now, I want to give you an example from a computer science education perspective, which is, imagine you wanted to make a resource for your students around the topics that they should learn as they're thinking about, their journey into computer science. So if we did something like computer science advisor, there's a ton of great resources out there that you can use as context, and there's a ton of different tools that you could use to make actual utilities for your students. So just as an example, without providing anything in here, we could think of a type of question that a student might ask a computer science advisor that you would build for them. Maybe it's like, what are the 5 most important topics for me to know after my freshman year studying CS? And without any context, it's going to use the default training here. This advice may or may not be good, and this is certainly not in a Socratic method or any kind of like education-focused output structure. So it's given us some generic knowledge here with some basic things, but not a lot coming back to it. Let's say that we wanted to actually give this some information. So one of my favorite partners that we work with at Major League Hacking is this company CodePath. They're a nonprofit that makes open source computer science curriculum. Let's say that we wanted to actually ground some of our work here in some of their work and in their study guides for computer science. So if we add that as a source here, and we can see how this actually works with a GitHub repo. So if we go back to the repo, this has a variety of folders with information about things like graph traversal with some basic resources inside of it. So now if we go back to our advisor and we say, what are the top 5 topics I should know as a freshman studying CS after my first year? This time, we'll see that Copilot is going to, when it finishes thinking here, it's going to start actually searching the attached computer science guides. So you can see how it's literally navigating the repository and finding the specific information here in the grounded context of what the agent has access to. So not only are we getting similar answers, but they're actually grounded in the content that we gave it. rather than just generically looking at it. And we can ask it things like link to the sources in the repo. And so now, because Copilot has access to that repository and it has access to some of the content that we've created, it's going to be able to literally do that in line, and we can click out to some of these things and see directly in the interface what it was talking about. So this is about pointers on strings. The other thing I wanted to show you here that's kind of interesting is the other day I saw this post about Stanford's CS 336. So this is specifically a context file that they give to their students to give to their AI agents in order to get better interactions around and how they do things. So I'm not going to go into reading this yet, but I will. I'm just going to copy the file, and I'm going to go back to our computer science advisor, and I'm going to paste that in here as part of our instructions. We're going to cut out some content here to help this be a little shorter. Let's see. I'm just going to get rid of some of this stuff, and then maybe we'll get rid of this a little bit more. Okay, there we go. So we do that same exercise here, which is what are the top 5 things I should know as a freshman studying CS at the end of my first year. This time, again, we're going to have responses grounded in the actual data and repository we provided. It's going to have some guidance from the system prompt about how best to respond to students and help guide them, but it's going to be tailored to our learning style. So we're looking here, it's actually pulled in information about the course. I didn't remove all of those references, but you can imagine how you could create one of those system prompts for your course, for your students, asking it exactly how, or helping the AI understand exactly how to interface with them using maybe a teaching methodology like a Socratic method, or without giving the answers, things like that. The last thing I want to focus on here before we go, because I know we're going to run out of time, is Spark. So Spark, as I mentioned before, is a new tool from GitHub built on Copilot that allows us to actually create dynamic web pages and apps just from natural language. So we're going to combine a couple of different things here that we want to do. Let's say that we've got our computer science advisor, and we're actually going to get rid of our guidelines here just to keep things from getting confused. But so in Spark, we're going to actually create a basic flashcard game that our students can use to study based on those open source guides that we got from that repository that we attached from CodePath. So what we're going to do is we're going to ask it to write a PRD, which PRD is just an industry term for product requirements document. All it does is tell the agent what we're building. And we're going to say keep it short because we don't have a lot of time today. Keep it short for a coding agent to implement a basic flashcard game using this study guide from the repo on one topic. I know, let's do strings. So again, we're using context to generate better prompts in the language of an expert that we're going to feed into another AI to get the output of what we want, decomposing a bigger task, which is we want to make a flashcard game into smaller steps that we can then compose together. So here we go. We're getting our little PRD. This is pretty good. And then we're going to go back to Spark. We're literally going to paste all that in. I'm just going to get rid of the little preamble there and hit go. So this is a slightly different interface than we saw with Copilot before on the web. This is what, if you're familiar with, like, again, a Lovable or a Replit or something like that, this is going to look a lot more like that. On the left side here, we have our chat with the context about what's happening. So we can actually see here that my PRD text is what we're working on, and we can see that Copilot is thinking and getting ready to start generating. We'll be able to follow along with what Copilot is doing here. On the right side, this is where, when our app is built, we're actually going to see it. But if we click over to code, we can literally watch the agent write code as it does it. So it's creating a beautiful and engaging flashcard app there. And then we can actually even see both if there's a side-by-side view. A couple of other things I'll call out here is that as you get more advanced with this, you can attach other things like data and prompts and assets to basically theme these things or like give it access. So let's say we wanted to specifically upload flashcard data that we wanted our app to use, we could do that here. But at its core, the way I would think about this is these are throwaway tools that if you're trying to think about a clever way for you to help your students either with synthesized learning, practice using AI, or like other things like that, you can use Spark or just Copilot agent, which maybe we'll talk about for a second while this is building, to actually do that. So because we're not going to have time for us to get into everything here, I am going to click over to this agent tab really briefly. Agents are very similar to Spark in the sense that the idea is that this is a fully autonomous agent that can go on GitHub and interact and do things. Specifically here, where you could ask it to like go out and attach it to a repository and go build something and open pull requests. If you wanted to make reusable, maintainable software that you wanted to keep using time and time again, rather than just a disposable prototype, this is where I would start. But very similarly, you can write a PRD or other document using AI and then actually give it to Copilot to go out and do. And this is more of like the agentic coding that most people will be familiar with. In the spirit of time here, I'm just going to pop back and see where we're at. We're pretty close. While it's doing that, though, I'm just going to actually pull up one that I did earlier today, just because it probably will be a little faster for us to look at, so I can just be honest on timing here. But if we go back to Spark, I literally did this morning or a couple hours ago, where I literally had to do a flashcard game for AP computer science students. So it's just loading itself right here. The first time you open one of these pages, it'll have to do its load. But this already has the code pre-generated here, which hopefully it will load pretty quickly. Maybe this one will finish before our other one does. Come on. Well, I'm hoping we'll get a live demo here for everybody. Let's see. We may have to take my word for it, but we will come back in a minute. Oh, there we go. Great. So here's an example of the one I did earlier while the current one is building. But again, this is just literally a basic app. This is written in React, if anybody cares, but it actually does not matter. Again, if we think about this as a unique methodology for helping our students learn things and creating utilities that serve a moment in time, like studying for an exam in a fun and engaging way, this is exactly the type of thing we would use vibe coding or like these types of assets for. And then it's a good thing I'm not taking the AP computer science exam, because I don't know that I'd be able to answer half these questions just off the top of my head. But you can see this is literally a one-shot prompt. Without a very good PRD, it was able to do this. But we can literally go back and forth and say like retheme to be more retro. And we can do that iterative kind of planning and thinking we were doing before. So with that, I know that I'm coming up on time here, so I am going to come back to the deck really quick and just finish up one thing before we wrap here. And then Morgan, you're just keeping me honest on time here. I have another like 15 minutes for Q&A, or we need me to wrap up now. I know that we changed that a little bit.
Yeah, no, you're fine. You could go another 30 if you need to.
Oh, amazing. Okay, we can definitely do more of that. If people are enjoying it,
Yep.
I'm happy to do it. I might pause just briefly for the deck here, and then we can go back into building more things. I had it in my head that I was running out of time here. So we've talked about a few of these things around creating reusable context files, doing this iterative loop, having AI generate our prompts, and using the expert language. Again, these are the types of things that I would say that if you were going to give your students skills in AI that are going to set them up for success in your class and beyond, these are the types of generic, specific skills that I would be focused on. Again, there's not good examples of this stuff in industry. We need to model it, and we need to break people out from the paradigm they're used to, which is like an advanced Google search. And so specifically, I would be thinking about how to give them tools like these that are going to enable them to translate this into other classes or other places they're using them. I am going to answer some questions in a second here. I can already see some in the chat. So I'm just going to encourage anybody who has questions or like wants to see specific things, dump those in the chat. I'll go through them live as we go into it. And then I am going to pop back over and just finish up that example on the GitHub Spark so that we can see some things like where that gets deployed here. So let me reshare my screen. I'm going to do this slightly differently. Put this back over here. There we go. All right, and then we're going to share that screen instead. So now I can see the chat and, okay. All right, so I saw a question in the chat, which was, okay, we've made this flashcard game. How do we actually share this thing? So there's a couple of different options that we have for that. We're going to stop Copilot from working, and we're just going to hit publish here. So there's a big green publishing button. It allows us to actually share our work. This is going to give us back a URL in a second here. But we also can create a repository or a code space from the code in our Spark. So if we wanted to, let's say that we used Spark, and again, just mental models here for everybody. Spark is like ephemeral, throw text at the agent, see if it builds basic web apps, some more advanced functionality, but again, disposable code. This is about creating mediums for exploration. When we're like, oh, we want to make something that is tangible and it will last for a long time, we're probably going to use Copilot agent, and we're going to build that inside a repository where the agent is going to continue to compound that work and build an asset that we're keeping for a long time. If we did want to transition this like prototype to that, we literally can just click that this button right here, this create repository, and it will take all of the code that's in here and dump that into a repository for us. Now, this is an example of the flashcard app. Let's see, I'm going to make this visible to anybody on GitHub, read only, and let's see if we visit the site. Great, and I will put that in the chat there in case anybody wants to try it out themselves. But that is an example of how you can share it. It gets its own URL up here at github.app, and we'll kind of give you the idea of how you could share that with your students. You could also share write access. So if you wanted to make sample applications that they could then remix and do things with, you can literally you can do that as well. So you saw that I gave everybody read-only access, but you could literally scope this to just your students or read and write, or like things like that. There's a couple other interesting things here. So again, this is like a more fully featured coding agent and environment rather than just a chat. So we could do things like, for example, let's say I can take this and like, let's say we're going to target right in here, and we can actually edit things like, let's say we wanted to change our font size to be really big or something. Okay, so it's not going to do that. Well, we can change things like the color. Maybe we make this teal or something. But you can see how we can kind of play with these settings here. We also can look at things like mobile view if we wanted to, make sure it's mobile friendly. And if we wanted to adjust the actual, if there is AI capabilities, you can adjust that in the prompts and things. Again, I want to emphasize that these are meant to be iterative. This is an example of one that I made before. Maybe I'll actually follow through with my retro one, and we can look at the other example that it came up with. So this is the one that was based on the context from that repository we had before. I don't know if it, oh yeah, so it actually did create some data sets here that we can look at. And so this is actually a really interesting example where if you had custom questions or content that you wanted to add from your course, you could literally come in here and edit these things and add, delete, whatever you wanted to do with them. Let's see, we're gonna go back over here to Copilot. Copilot, there we go. A couple other things I want to call out on. Maybe we'll just really look briefly at having an agent go do something. I'm a big believer in this idea of reading code as a mechanism for understanding. And so having agents actually work with your students to understand sample code is another really great exercise. So I really like this explain repository tool. I'm going to pick something that actually has a real, what has a real, so I have a ghostwriter repository. I'll have it use that here, but we'll have it explain the repository to us. But these are really good examples of how this is going to be more asynchronous. So rather than in the chat where we put in a prompt and we expected an immediate response, a mental model for you when you're thinking about how you interface with agents and how your students would interface with agents is that agents are much more asynchronous. So we can see that this is actually queued work right now. It's going to be operating in a cloud environment. And so we can click through and actually see what's happening here. But when we kick off an agent, in the agents tab on Copilot, that is asynchronous work that's going to happen, and then we're going to come back and find out the results of it later, rather than, again, the instantaneous kind of call and response we would get with a normal Copilot chat. And so actually maybe the example I just gave you is maybe a bad one for that particular use case, because you probably would, if you were a student wanting to dig into a what I would assume would be a reasonably small code base in a classroom setting, then you probably would want to do that in an instantaneous fashion rather than asynchronous. So I'm going to look at a couple of the questions here in chat, just to see if I can get people, make sure everybody's got questions that are going to be answered. There were some questions. So the first one here is a professor who has no knowledge of coding at all. They've designed an app. So if you wanted to create a new application, can I only do it using GitHub Copilot? So no, that is not necessarily a constraint. We're just demoing today a single interface using Copilot. How do I want to explain this? So when most people talk about an agent, they actually are referring to what's called a harness, which is just like the wrapper the agent operates within. So for example, GitHub Copilot is a harness, which is like the context that an AI operates in. The specific AI we're using for this example is Claude Sonnet, which is one of their models. That's literally the specific set of training data that the AI actually generates from. And we're specifically asking GitHub Copilot, the harness, to do things with that. Claude or Claude Code or Claude Cowork is just a different harness that may use some of the same or different models. I like GitHub Copilot as a harness for coding related work because it's already, first of all, it's browser based rather than me having to like have people install custom software. VS Code is obviously widely distributed and has Copilot baked in, but in terms of getting people going, especially beginners, this web interface is the best. And then two, it's already on GitHub. So rather than having to connect my Claude to my GitHub and like do all these different things, like it's all just baked in and natively here. But no, if you made any code that you generate from Copilot and you store it in a repository, you could literally have Claude or Codex or Gemini or Anti-Gravity or whatever touch and use it as well. The beautiful thing about doing things on GitHub is that repositories and Git are these like universal tools we can always use. So somebody asking about hosting and serving on GitHub. Yes, GitHub has a bunch of tools baked in for helping you actually serve pages, whether that's GitHub Pages or other things. We demoed one with the Spark using GitHub.app, but yeah, those are definitely possible. There's a question here around possible to parse it so that it works under a school domain instead. So my general advice would be that if you were having trouble with getting access to domains or like GitHub, first of all, you should be working with your school's IT department because blocking GitHub is just an insane decision for so many reasons at any school. But they should try to get access to GitHub URLs. If you're not able to distribute GitHub URLs, the other beautiful thing about this is that you could distribute the actual HTML files. So, for example, this flashcard app that we made, while it is written in React and this code is designed to operate in a generic kind of JavaScript environment, this will literally work in any browser. If I downloaded this set of files and gave this to a student, they could literally open up index.html in their browser locally and access and use it. So in addition to being able to, if you cannot get GitHub URLs for deployment unblocked, you literally could just distribute the files as HTML directly. Spark is only available in Pro Plus, so just as a heads up, if you have regular Pro, you might not have Spark. But again, if you want to do any of the things we just did, literally just to be really clear about how you could do this without having access to Spark, we're just going to grab our PRD here, and instead of doing that the way that we did with Spark, we're actually going to go back here. You would literally just do that with Copilot agents, which you should have access to. So if I do have an MLH repo for this. Here we go. Implement this PRD, which is a terrible prompt, but you'll follow the lessons I gave you already instead of doing what I did. But you can see how we literally, let's see what happened here. This rep is not found. Oh, because it doesn't have a right. So the challenge with what just went wrong, which may not be obvious to everybody else, is that that repo doesn't actually have anything in it. So when you create, we can actually just create a new repo just to show everybody how this would work. But or maybe we can add something to that repo really fast. Let's see, GitHub Education. Really? Let's see, here we go. And we're just going to recommend. How are we going to do this? We are going to do this like this. Okay. Actually, we're just going to make a new repo is what we're going to do. To make my life a little easier here. So we're literally just going to make a new repo just so that I can shut this off. We'll put a README in it so that it's got something. Okay. And now we go back and grab our PRD again. And we go here to agents, and we're just going to give the page a little refresh. And we're just going to go to demo. Come on. Let's see here. All right. There it is. All right, we got it. Implement this PRD. And I lost the PRD. There we go. All right. So that's time, because it actually will have a branch on it. You can see it's queued. So we're going to its PRD. It's going to set up the environment. And then literally it's going to do the same thing that Spark did, except the interface is just slightly more complex because it's using the asynchronous agents feature rather than using the Spark abstracts a little bit of that away without creating a repository in your profile specifically. So anyway, all of that was a dramatic way of saying, yes, you may not have access to Spark if you don't have access to Pro Plus, but don't worry, you can still do the same thing we just did using regular GitHub Copilot agents instead of Spark. There's some questions in here around database functionality and some things like that. Yes, the agent has the ability to actually do those things for you. We have not demoed any of those advanced features, but like you could have it do things like authentication, databases, maybe email or SMS activity. The more complicated your app gets, the more requirements it's going to have for hosting or other services. But in general, yes, you can do all of those things here in the same way. Somebody asked, could I have had the agent create the repo for me? I would assume yes. I typically don't do that just as good housekeeping for myself, so I know every repo I'm creating. But yeah, because Copilot is baked into GitHub, it has access to a lot of basic GitHub features like creating issues or repositories and things like that. So yeah, I probably could have and should have. And again, this is maybe not being AI native. This is maybe a sign that I'm a little farther on the left of my my hierarchy, but yes, the idea is an AI native thinker would probably go to the AI to ask it to do what I did instead of doing that manually. And then PRD, yes, means product requirement document. PRD, and again, this is the key piece I want you to take away here is that better inputs, better outputs. PRD is an industry term that people who write software use to basically just describe the list of requirements for the software we're making. By using the word PRD, I'm signaling to the AI that it should be using things that a software engineer would use. And so you don't necessarily need to call it that. You could just call it whatever you wanted to. But again, I'm trying to, in the example here, use language that an industry expert would use to generate generally higher and better quality results. But that's a great question. And honestly, PRD, most people probably didn't know what PRD was until the last year or so when it became popular with agents to use them. So we can see here what Copilot's doing. Again, I want to emphasize that this is basically the same as what Spark was doing, except a different interface for doing it. And so again, the key piece here is that the agent is operating asynchronously. It does not necessarily have those preview features that we wanted to see before, but we can see, like for example, the code changes here and eventually we'll actually open up a pull request with these changes in it. So same ideas, just a slightly different interface, and all of this is built on Copilot, which is what enables all of it to be able to do these things in the first place. Cool. And let's see if we'll get to actually doing some. So the other thing that's nice about this too, and especially if you have students who maybe are not as well versed in computer science fundamentals or have not written production software before, Copilot has a bunch of things baked into it, like checking to make sure you're not leaking environmental secrets, or that the code quality maintained is actually high, but at a high level at a high level. Maybe it's got some more guardrails than if you had just kind of like sent somebody off to go figure things out on their own, which is another great tool for that. So I'm gonna give it another minute here and see if we get to a pull request just to show what that looks like. But otherwise, if there's any other questions, definitely toss those in the chat. Happy to answer them. And I think we will wrap up here momentarily. Question here is there a difference between using GitHub through a browser or via an IDE like VS Code with Copilot? So yes, I specifically would recommend to all of you, if you have the option, to do things in the browser. The reason I think that that's important is twofold. One, it's universally accessible and understandable. I don't need to install custom software. Not everybody has a laptop that is, able to accommodate writing code or running files or servers and things like that. Also, no matter where you are in the world, you have the same context. So, for example, if I forget my laptop at home, I can still open up Copilot on the web and have access to all of my repositories without having to do anything besides log into GitHub. Second, I think that the classic way that people use Copilot integrated into VS Code is locally, which means that your sessions, A, are not parallelizable if you're writing code, and B, are not natively parallelizable, and B, are constrained to the laptop or the computer that they're running on. And so what I mean by this is I could literally open up GitHub on my phone or on my laptop, even though I'm presenting on my desktop right now, and open up this same session no matter where in the world I am, versus if I was running this locally in VS Code, I would have to have configured it so that that was the case where I could see it remotely. So there are differences. Using it in VS Code is much more powerful and configurable. You can do things like install skills, customize the agent's experience more easily. All the things in the web are designed to be abstractions that make it easier for you to do things, but it certainly does not have the power of what you could do if you did either the command line or the VS Code integration. So we finished our little app here. We can create a pull request with this code just to see what that looks like. And in fact, we can request Copilot to review its own code as well. And then let's see, at Copilot. And so the other thing you can do here is you can have a conversation with Copilot on the pull request. So I'll be like, can you make sure this is viewable on the web via GitHub pages? And so we can have a little back and forth conversation with the AI, have it do things in between, and then we can even, if you are confident enough to look at the code and see what's going on, this is a great example of how we can go in there and do that same GitHub interface that you already probably know and love. They got another question here, which is there a good set of objectives for a hackathon running over 1 or 2 lectures? Yeah, so I'm not going to read the whole question here, but like basically the question at the highest level is what is the guidance in terms of what people should work on in a hackathon? So my general advice here, and I do literally, whether I'm running into a student at a public hackathon on a weekend, or if I was advising a faculty member who was running one, or a company, because I literally do this as an example. We at Major League Hacking, we help Google with all of their internal AI upskilling through hackathons for their non-technical employees. So like marketing, sales, public sector, we're like using hackathons to teach people how to use Gemini or other AI tools there. Regardless of which of those particular instances, I always tell people the same thing. Pick something small in your life that literally you deal with every day. It doesn't need to be a world-changing problem, but pick something real to you that if you solved it would actually make a difference, and go out and solve it. And often the silliest little things are actually the best projects because you literally make things that you use every day. So for example, for me, one of the first tools I made at an internal MLH hackathon was a web page summarizer, which sounds really trivial, but for me, as somebody who gets sent tons of links every day by my team and customers, and I need to like figure out which ones are actually worth reading and spending the time on because I really don't have time to do all of it, writing a simple prompt and agent that basically would tell me which links were worth my time was a huge lifesaver. Another great example of that is, we had, during our internal hackathon at Major League Hacking back in December, we had somebody from our sales team and somebody from our community team who came together and made a chatbot that lives inside one of our Slack channels. That's literally our most popular Slack channel where people can ask questions about the data in our databases. So for your students, and like to come back to the question, I would literally encourage them to come up with their own product ideas. Like you can do a lot in 2 hours. Stuff has been pretty trivial, but if we literally spent 2 hours focused on a single problem, like updating this website for our school, or making an actual application to help people study and prepare for an AP computer science exam, those are real problems that we could spend a cycle on and make something that's a heck of a lot more robust and material than what we did here. So all that's to say that I would encourage people to be open-ended. I would encourage people to solve real problems. And I would do lecture 1, basically do exactly what I did, open up Copilot and show them some of these tools of the trade, like how to write a prompt, how to get code back, how to, merge the PR. And then lecture 2, I'd be like, great, you're spending the whole class making something. By the end of class, you need to have a 5-minute demo ready of what you made. It doesn't matter if it works, it doesn't matter how good it is, but you do need to show off what you made and talk about what you learned along the way. With that, I think that's going to be basically the end of my time here. There's one more question here, and then I'll answer, and then we can wrap. But the question is about CLI versus IDE. So CLI stands for Command Line Interface. IDE stands for Integrated Development Environment. IDE is like a program on your computer where you write code. So if you think about VS Code or Vim or Emacs or IntelliJ, these are like literally environments where we're writing code. So that's an integrated development environment. A CLI is a program on your terminal that you run that literally just interfaces with text. And so Claude Code is a terminal tool. GitHub Copilot CLI is a terminal tool. Listing, with the contents of a directory is a terminal tool. So it's just like, what is the interface in which we're interacting with AI? Again, you could do web, you could do it in your IDE, you could do it in your terminal. I prefer web because I think it's way more approachable and understandable. But in general, I would say that like, if you just want to know what they are, it's just about preference of like where you want to do your work and interface with AI.
And I can share some really great CLI resources. We've been using the CLI just on our team, and everyone loves it. We love the CLI. It's really fun, and it can be really nice and handy, especially if you want to do just kind of like simple commands, just kind of like text-based stuff, and that will kind of like help. It's helped a lot in actually just like everyday productivity for some of the things that we're running, just to let it get data reports, have something like run every month, so we get a report on how this is going or how that is going. So recapping things, like it's been really, really great. Let's see. And then there's also the app.
Oh yeah.
There's all kinds of things coming out. The app is so new. That'll be the next summit. Will probably be all about the app. We have one more question here. Maybe Swift, before you pop off. At what point in the CS curriculum should students start using AI to build applications? After they have mastered the concepts of software engineering and programming, or right away?
So I think right away, and I definitely have some bias here, but like when I was a student, the zeitgeisty thing was that Wikipedia was the devil. And you would go to class and your teachers would say, never trust Wikipedia. Don't ever use it for research because random people on the internet edit this thing and like you never know where you're getting. Reality check, Wikipedia is literally the modern version of Encyclopedia Britannica, democratized to anybody in the world who wants and needs encyclopedic knowledge at a scale that is completely unheard of. Telling a student today, don't ever use Wikipedia, is missing the forest for the trees around how they should think about doing research and what they're thinking about. AI programming is the same situation in a different light. Telling somebody not to use the tool is not teaching them the mechanics that they need to know in order to like be a successful in the modern world, both as a human and as a knowledge worker. And my advice would be, rather than thinking about the separation between this tool and fundamentals, this way of doing things, the old way of doing things, whatever, I would just think about how do we set people up so that they have the specific toolkit that they can rely on, where they can solve meaningful problems with the level of competency and mastery that they need to know. And for a computer science student, my argument is that a computer science student who, and we actually use computer science as a catch-all for practitioners and theoreticians, but I would actually say that the core mechanic of computer science classes right now is teaching people to think critically about code and translate human requirements into machine requirements. And if a student can do that and rationalize about it and problem solve on a variety of patterns, I think that's a pretty good starting point, using AI or not.
Well, for lack of a better term, I think that's a really great mic drop. We will, I think we'll close down your session. Thank you so much. So much in the chat was saying like how much people loved your analogies and just the way you were describing and going through your demo and the way you're describing these concepts. So I really appreciate just your presentation style and what you bring and your energy.
Oh my gosh.
Really inspiring.
Everybody steal them. It would make me so happy to hear a bunch of students saying that they heard this amazing thing from their actual teachers and heroes. So no, please by all means. And I appreciate the kind words.
Awesome. Thank you so much. Just housekeeping for the rest of the group. We're going to break for about an hour. When we come back, we will be with Ari again. If you joined us yesterday, Ari, one of our senior program managers. Yeah, he's going to be coming back to dive a little bit into some of our credentials, what those mean to you, how you can kind of like explore these different credentials for yourself, or how you can kind of recommend and what to recommend for students. And he'll also dive a little bit into spaces. He's got some agentic workflows that he can also walk us through. I might have him also do some CLI work for us as well, and so we can see what's going on in command line. But yeah, we're going to do some more stuff in the afternoon. So please join us again. And thank you so much to Swift for joining us today. Really, really great session. Thanks so much. Bye.